and the tutorial at home if you want to study it yourself. There are exercises in the tutorial with answers at the back, but I won't be doing those exercises today. This is not a hands-on session. I'll just be going through the examples. At any time, if you have questions, and also give me feedback about anything about the tutorial. If you do it at home, you have three zero install implementations. That is that they are all accessed via a browser. John Lumley's JWI XML, Alan Couture's, I think he calls it Grammix actually, and my own example. The first two are much faster than mine, but mine does more analysis, and I personally believe that the error messages are a bit more understandable. Just as a recap of what iXML looks like, this is not a beginner's tutorial, so I'm assuming that you know something about iXML already. But a rule is a number of alternatives separated by semicolons. Each alternative is a number of factors separated by commas. And each element of an alternative is either a terminal, which are either strings or encoded characters, or character sets, which just matches a single character in the input. You can include insertions, which only appear in the output, and also an element of an alternative can be a group or an option. And a group is just a number of alternatives, again, separated by semicolons. An option is just an element followed by a question mark. And there are four types of repetition: 0 or more, A star; 1 or more, A plus, as in normal grammar representations, but you can there's also 0 or more with a separator. So A star star B is either an empty string or an A or an ABA or an ABABA and so on. And 1 or more with a separator is A plus plus B. To control the serialization, you can put a minus before a terminal or before a rule name, which says do not include that thing in the serialization, but for a rule name, it only excludes the name, the element, but it still includes the content. An upward, a cap says do include it in the serialization, but you hardly ever need to use that because it's default. And finally, an at before a rule name serializes that as an attribute rather than an element. There's one new part of iXML that's not in the 1.0 specification, but has been added since then and is present in all implementations, and that's renaming. If you've got a rule name, you can do greater than and another name, and that means that that rule is serialized with the different name. So, for instance, if you've got a numeric month, but renamed as a month, and that can be a digit followed by, optionally followed by another digit, then that will turn up in the output, in the serialization, as a month and not as an end month. Okay, so on to the first case study. I think there are 7 or 8 case studies in an hour and a half. So the first one is a fairly simple one, and that's representing an IP version 6 address. Traditionally, for syntax descriptions of programming languages and so on, they're used to describe what is acceptable in that language, but they don't really they're not really interested in presenting any particular structure. On the other hand, iXML is different in the sense that it's principally the structure that we're interested in because we want to add markup to the output. And to a lesser extent, are we interested in the correctness of the input, because in many cases we'll just be transferring some existing input which we assume is already correct. So we won't necessarily have to check that it's correct. So we talk about two types of grammar: permissive grammars, which assume the input is correct and is only interested in producing the XML, I beg your pardon, and strict grammars, where we are interested in checking that the input's correct as well as producing the XML. So, for instance, if we're going to take IP version 4 addresses, well, that's a 32-bit number, which is represented by splitting it up into 4 groups of 8 bits, where each group is represented by up to 3-digit decimal number. So, for instance, 192.168.1.2. So if we wanted to describe this, the most permissive description of this would be to say it's just a bunch of numbers separated by full stop. So it's not checking that there are only 4 of them, and it's not checking that there are up to 3 digits, but it does recognize that they're digits. So that's the most permissive version. If we wanted to be a bit stricter, then we could say, well, there are only 4 of them, so D3.D3.D3.D3, and where D3 is 1, 2, or 3 digits, and the digits are still the same. So if we know that the input's going to be correct, then this is fine, because this just converts it into an IP version 4 structured address in the XML. On the other hand, we might want to check that the number of digits is correct, and it's only up to 256, 255, I should say. So here's a version of D3 that checks that it's either a single digit, which covers 0 to 9, or 1 to 9 followed by any digit, so that covers 10 to 99, or a 2 followed by 0 to 4 followed by a digit, so that covers 200 to 249, or 25 followed by 0 to 5, which covers the cases 250 to 255. So in this case, this would check then that an IP version 4 address is actually correct, so this is then a strict version. Similarly, for dates, you can adopt a similar permissive strict approach. You can either say a date is 2 digits followed by a slash, followed by 2 digits, followed by a slash, followed by 4 digits, or in the same way as I just did for D3 above there, you could restrict the values accordingly. So if we now look at an IP version 6 address, well, this is a 128-bit number. And it's represented by 8 groups of 16 bits, and each of those 16 bits are separated by colons. Each group is represented by up to 4 hexadecimal, not decimal digits. So, for instance, here is an IP version 6 address in its full form. So if you were going to accept just that, then it's very easy. So if we decide to be permissive with this and not restrict it to 8 groups, then we can just say it's a bunch of H4s separated by colons, and the colons are being deleted there in the output. And then we can say an H4 is just 4 hexadecimal digits, and hexadecimal digits are either 0 to 9 or lowercase a to f or uppercase a to f. However, an IP version 6 address has some shortcuts. First of all, leading zeros can be admitted, but at least 1 digit must remain. So we say an H4 is an H followed by, optionally, 3 digits, and 3 digits is an H followed by optionally 2 digits, and so on. And the other thing is that the leftmost longest string of 0 values may be replaced by colon, colon. So that is to say, you look at all the zeros in a particular representation. So up there, you've got 2 lots of zeros stuck together. So you can replace those by colon, colon. And so that means that everything in that colon is just zeros. So we could represent that by saying, and again this is a permissive version. And version 6 is a number of H4s, 0 or more H4s, separated by colons, and then the zeros representation, which is colon, colon, and then some more H4s separated by colons. So the nice thing about this is that the resulting serialization has this element called zeros, which means that there's just a bunch of zeros here. So since there have got to be 8 of them, that means we've got 2 H4s, and then 5 lots of zeros, and then a 1. So there is an exercise, if you're interested in doing it, and that's to make this so that it only accepts up to 8 fields. So it's kind of tough because the zeros means that you have to do some counting, as it were, in the grammar. But you never allow, the exercise asks you to never allow more than 8 H4s in the output, but I'm not going to do that today. Right, the second example, a fairly simple one, is comma-separated values. It's from spreadsheets. It's derived from spreadsheets. I couldn't find a formal definition of it, but it's so often used, it's worth having an IXML grammar around for it. So I just took this example of CSV from the Wikipedia page on CSV. So they're just comma-separated values, one row for each entry, and in general, a value is anything that hasn't got a comma in it, unless you put quotes around it. So what we can see is that CSV document consists of a number of rows. So CSV is a row star. And each row consists of a number of values, comma separated, followed by a new line. So that's V star star comma, new line. But of course we don't want the commas in the output, so we delete the comma there. So I should just mention this here. In the original version of IXML, that's the standard version now, a new line is whatever the operating system gives you. So although on Unix, for instance, or Linux, it'll just be a hash A, on Windows it'll be a carriage return line feed. So this covers both cases of Windows, or all three cases actually, Windows, Linux, and Macintosh, that you say a new line is optionally a carriage return and then a line feed. But in the next version of IXML, we've decided we're going to normalize new lines, and so that you always only just get a hash A, even if the operating system uses a carriage return as well. So a basic value within CSV consists of any number of characters as long as they aren't a comma or a new line, of course. So that's fairly easy to define. It's just a tilde, comma, hash A or hash D, and any number of those, including 0. However, as I said, it's possible to quote a value so that it does include commas, and so you either have a quoted or an unquoted value. The unquoted value is just more or less the same, except now we're also excluding a quote as the first character. So the first character can't be a quote, or a comma, or a hash A or hash D. And then after that, you are allowed to have commas and quotes. And of course, an unquoted value is also allowed to be empty. Again, there's an exercise to do the quoted version. But if we take the above example that I quoted from Wikipedia, then this is what a CSV value for that. An XML result looks for that value. So it's a number of rows containing a number of values down there. So there's quotes in it, and at the bottom there's one with new lines in it as well, because it was quoted. And finally, of course, as an extra simple example, if we put an empty file through this grammar, then we just get an empty CSV file. Okay, so my next example is ls minus l. So in Unix-like systems, the command ls produces a directory listing, and ls minus l produces a long version with more details. So for instance, here's just a simple example, 2 directories at the top and then 2 files, and an empty directory just consists of a total of 0. So if you want to turn this into a structured version, then it depends on how the IXML works on your system. For instance, it might work like this: ls minus l piped through IXML using the grammar ls.ixml. And the ls.ixml is what we're now going to deal with. So at the top level rule is going to look like this. It's going to be the total line and a number 0 or more entries. The total we're going to put as an attribute, and that's the word total and a space, which we're going to delete, followed by a number, followed by a new line, which we're also going to delete. A number is just 1 or more digits, and a digit is 0 to 9. So an entry, if we're now going to define entry, then this is what an entry looks like, and it consists of the properties, the number of links, the owner, the group of the owner, or the group of the file, I should say, the size of the file, a date and possible time, and then the name up to the new line. So some of these are very easy to do. So the number of links is just a number, which we've already defined, followed by a space. And a space is deleted spaces, 1 or more of them. Although after the number of links it's a single space, there are some fields that are separated by more than 1 space, and so it doesn't do any harm to add the plus there. An owner and a group are both identifiers, which for the time being, I'm going to say are just letters. In fact, it's actually more than that, but that's, I think, an exercise. So it's an ID is just a number of letters followed by a space, and a size, again, is numbers. Dates have 2 different formats. They both start with month and day, but then it's either a year, or if the year is the current year, then it's replaced with a time instead. So a month is a number of letters. A day is either 2 digits or a single digit, which in this case I've turned into 2 digits by adding a 0 in front of it. A year is just a number. Of course, I could have said 4 Ds there, but again, we're being permissive because we're not checking that ls produces the right output. We're just assuming it produces the right output. And the time is an hour, a colon, and a minutes, followed by spaces, and of course an hour and a minute are both numbers. So it leaves 2 more things to define. Again, it's a permissive grammar, so that makes life easy for us. So the properties of the file, which is that odd string at the front, we don't have to know what the characters are that are allowed there. We can just say it's anything that isn't a space, because it's terminated with a space. So we just accept any character there up to the first space. And so that gives us a result like props and then the 10 characters that make up the properties. But since we know a bit more about the structure of that, we know that the first one is the type of the file. The next 3 are properties for the user, the next for the group, and the next for everybody else. And so we can split that up into those 4 fields: the type, the user, the group, and the other, and then a space. I've had to use GRP rather than group because earlier I'd already used the word group. Owner and group. But on the other hand, I do want it to come out in the output as the word group. So I'm using renaming to turn this element into a group on the output. All those three are attributes. And I've just said some character. Again, I haven't defined what the character is. I've just said I'm willing to accept anything that isn't a space at that point. And the one remaining thing we haven't defined is the name of the file. We're going to give that as an attribute. And similarly, because we're being permissive, we're just saying, well, it's anything up to the end of the line. We don't care what the characters of a name are. So here's an example of an output from that. We've moved the name right up to the top as an attribute, and then the entries have got the properties of the type, the user, the group. You can see it's been renamed, and the other properties, number of links, the owner, the group, the size, and then the date. Okay. The next case study, doing quite well for time, is dealing with DocBook bibliographies, and actually I use this all the time because this conference and Balasage both require your paper to be in DocBook format, and I've always found that getting the bibliography into DocBook format was always the hardest bit to do. So what I did was just design, just use the text version of the bibliography as it will turn up in the paper as we see it in the PDF, and then use IXML to convert that into DocBook bibliography entries, and that saves me the trouble of having to remember what all the field names are. IXML wasn't designed to produce particular versions of XML. In this case, we really do want to produce a particular version, but we can use IXML to produce something very close to what's necessary, and then just hand tweak it at the end to put it into the paper. So yeah, so here's an example of what I wrote as the bibliography entry. So there's the bibliography entry for the IXML spec, and then I process it with an IXML grammar to produce my DocBook bibliography. So a bibliography is just a number of bibliography entries, biblio entries, I should say. And a biblio entry consists of an abbreviation, either an author or an editor, a title, a publisher, a publication date, and optional page numbers, and then any number of optional bibliomiscs or biblioids, which I'll talk about in a moment, followed by a new line. So this, I've just designed that, but it's actually how it comes out in the proceedings in the end. So I'm converting it to DocBook, and the book's converting it back to text that I gave it in the beginning, which is quite amusing in a way. But I chose to just do a fairly fixed format. Field separator is a comma, like CSV was, comma and a space. Again, it's largely permissive because I'm writing the input, so I know what I'm putting in there. So many fields are just defined as any string of characters that's not a comma, or a closed square bracket, or a new line. So, for instance, I just say a title is an entry, and an entry is one of those things. A publisher is an entry, similarly, and an entry is just anything that doesn't include a comma, a closed square bracket, or a hash A. There are some optional fields, and then you really have to identify those because to be able to tell the difference. So, for instance, page numbers begin with PP. Bibliomisc, which is a web address, begins HTTP, and a biblio D is either an ISBN, which begins with the characters ISBN, or a DOI, which begins with DOI colon. So that's how I identify which of those is. So then, when I push this string through my grammar, then I get my very close to correct docbook bibliography entry, which then I can tweak by hand. There's an exercise here to allow, in the tutorial, to allow commas in entries by quoting the entries. I didn't add that myself until the time that I published or wrote a paper for this conference that included a comma in it, and then that forced my hand. Okay, we're doing very well indeed. So, GEDCOM is a non-context-free format for recording genealogical data, so family trees, in other words. It's, quite honestly, an awful format. The very fact that it's context-free already, that it's not context-free already says that there's something wrong there. I would say it looks like it was designed by a programmer who used assembly language. So here's an example of the format that's used by GEDCOM. There are now later versions of GEDCOM, but this is still widely used over the internet for representing family tree information. So why it's so awful is that the leading number tells you the nesting of that element within the structure. So 0 is the outer element, which has, for instance, a name field and a sex field and a birth date field. And a name field has a surname field, because that's a 2, that's nested within the 1s. And down here, you've got the birth date, so Bert, which has fields date, that's the birth date, plaque, which is the place, and source, which is a link to some source. And then source has a subfield itself, page, which says where in that source you can find it, and so on. So it's awful to write, it's awful to read, but it does represent family tree information. So what we will do is turn this into something more structured using IXML to give us an XML version. So at the top level, we have a record, any number of records, and those records are all numbered 0. And then a record has a number of fields plus a number of subfields numbered 1. So an R1 begins with the character string 1 space, and then that contains a field, and so on. And an R1 can have any number of R2s beneath it, and so on, all the way down. So we can go as far as we need to go. I haven't met a GEDCOM that goes further than 9, so this is all right. There may be versions with more than 9, but I haven't met one. But here we treat up to 9 levels of nesting. So what's a field? Well, a field, and this is just a simple version as an exercise that makes it a little bit more complicated, is a name, and then possibly an optional value. So it's a name possibly followed by a space and a value, and then of course a new line. A name seems to be any combination of A to Z capitals and 0 to 9 and @ signs. And a value, we don't care, it's any character up until the new line. So just that already gives us a very reasonably structured result of a GEDCOM value. Now we can really see how the nesting works. We can see the name and the surname and the given name and the birth details, the date, the place, the source, and so on. So that works quite well. What this reveals actually is that that it's not quite consistent because the resi has got an empty value, and that's because the source, the file that produced this, had a space after resi. It shouldn't have had really, so that we have a value that's empty because there's just a space and then nothing more. So the R1 and R2 are due to the fact that each level has a different syntax with a number specifying its depth. But luckily we have renaming, so we can rename all the R1s, R2s, and R3s. It still has the input syntax that begins with a 1, 2, or 3, but now it just gets output with the word field, and then it gives us this structure. So at the top level we have a record, and that contains a number of nested fields, which themselves may have nested fields all the way down. Again, in the tutorial there's some exercises to produce things that have got ats in it are actually links, sort of references to other places, and so rather than it being a value, we turn that into a link, and that's the exercise. So my, I think, last but one case study is for Markdown. Markdown, unfortunately, isn't a single language. It's a class of languages that's meant to make writing HTML text documents easier. There are several versions of them, unfortunately. They're all slightly different, and not all of them even have specifications. So I'm not going to choose any particular one here. I'm just going to show you how it works. I'll take the liberty of not using any particular version and just show, in general, how to treat Markdown with IXML. In fact, this chapter in the tutorial, the online tutorial, was actually produced using a version of the IXML that we're going to talk about now, on a Markdown version of the chapter, just to make sure it really worked and to show that it really worked. And also in the tutorial, it has a link to that Markdown version, so you can actually look at it. Okay, so Markdown, and again, this is an example of producing a particular version of XML, XHTML. So again, IXML wasn't necessarily designed to produce particular versions, but in some cases it is possible to do that. So since Markdown is just a different representation of an HTML file document, the top level is and has to be HTML : head and body, because that's the structure of an HTML file. So you have no choice here. You have to do it this way. Now, what's in the head? We could just leave it empty, or we could add a bunch of stuff. So just to show you how it's done, I'm going to add a meta and a title element. A meta consists of name and content, both of which are attributes. And so I'm going to insert strings, the generator for the name, and is IXML for the content. So we get this element out. And the title, I'm just going to call it Markdown as the title. So that's the head. Nothing particularly interesting there, but that's just to show how to generate content that isn't in the input. But then we get to the body. Well, just to keep it simple to start off with, headings and paragraphs separated by blank lines. So a body is a part separated by hashes. And if you wanted, you could add after that an optional hashe so that it doesn't have to be separated by, but you could have one at the end as well. So a part is either, and a part is not going to turn up in the serialization, is either some heading or some paragraph. And a heading, well, there are 6 levels of headings, H1 to H6. Those are going to turn up in the output. And a paragraph is a P, which is also going to turn up in the output. So let's look at H1s, headings. So they're identified, the level of headings are identified by the number of hashes before the text, followed by a space. Then you've got the heading text, and then optionally followed by a number of hashes. Again, we're not being strict here. I think that some versions of Markdown require the same number of hashes at the beginning and the end of the heading, and other versions of Markdown don't care about hashes at the end at all. So this sort of covers both cases. Heading text is a series of heading characters, whatever they are. Clearly, we have to watch out for hashes because those could be at the end, and we don't want the hashes to turn up in the output. So we only allow a hash in the content of the heading if it's followed by a non-hash or a non-new line. So here, if there's a hash in the heading text, then it has to be followed by a character that isn't a hash. Paragraphs clearly are not allowed to start with a hash because that signals a heading. So we just accept any character that isn't a hash as the first character of a paragraph, and then any number of lines, line characters after that. So a line character, for the time being at least, is anything that's not a new line. We keep the new line in the output, so we don't delete this hash A, so that paragraphs that are spread over a number of lines turn up as paragraphs spread over a number of lines in the output. Not strictly necessary, but nothing wrong with doing that. Now, text within a paragraph, you can also mark up in different ways. You can use a hash before and after some text for strong, an underscore for emphasized, and a backtick for code. So we change the definition of the contents of a line accordingly. So where we still keep a line as being a C+, and a character is either, is any character that isn't a new line or a star or an underscore or a backtick, and or an M, so an emphasized piece of text, a strong piece of text, or a code piece of text. And a strong piece of text is just a star, which we delete, followed by a number of C star characters, and then a star, similarly for M, and similarly for code. And so any character that's allowed in strong text is anything but a star or a new line, and the same for underscore and code. Finally, in this small example, we add one more type of paragraph, code blocks. Code blocks start with will produce a pre-element in the HTML. We'll start with a space in the input. So that means we now have two types of paragraphs, either a P or a pre, and we make sure that P paragraphs don't start with a space now, because only pre paragraphs are allowed to. And we define a pre-paragraph similar to P paragraphs as just a bunch of pre-lines with nothing special in the characters. So now for my last example, 9:30, 10:30, 11. So yeah, we're very early, but that's fine. For questions at the end. So my final case study is the actual grammar of IXML itself, which is quite an interesting one. IXML is defined using IXML, which means that you can produce a structured version of IXML in XML by just through its own grammar. The grammar has a number of interesting properties. So all meaningful characters are in attributes. All non-meaningful characters are deleted. We define spaces as being white space and comments. So a comment, and if you put a comment between two symbols, then that has the same effect as if there were a space there. White spaces are deleted, but comments are not. So comments turn up in the output. This makes a slight difficulty because it means the placing of space rules has to be done with great care so that comments don't end up in attributes. With one exception, the marks for a rule are on the definition and never overridden, with that one exception. And quite understandably, it's a strict grammar and not permissive. That is to say, it really does check that the input is correct. So at the top level of grammar is a rule. And so this rule actually defines itself. And it says a rule is a mark, followed by optional spaces, an optional mark, I should say, followed by optional spaces. Then a name, again, optional spaces. Then either an equals or a colon, optional spaces, a number of alternatives, and then a full stop. And you can see that, which characters are being deleted there because the full stop, for instance, is not a meaningful character. It's only there for syntactic reasons. Alternatives, then, are one or more alt separated by semicolons or vertical bars. And an alt is 0 or more terms separated by commas. And again, you can see spaces there. And again, you can see the characters are deleted in the input. So the rule for S is for optional white space, and as I said, a comment is treated as if it were white space. So it's any white space characters or comments. Its usage always follows a terminal, except if that terminal is in an attribute, and then it's moved to a higher level. So I've already said that, which prevents comments ending up in attribute content. So white space we define as any character defined as a white space character in Unicode. So actually there are more than just space. There's non-breaking space and thin space and a whole bunch of other spaces, which hardly anybody ever uses, but who cares? That's the definition of white space. Plus tab, which isn't counted as white space in Unicode, by the way, line feed, and carriage return. A comment is any number of comment characters or comments surrounded by braces. So, and a comment character is any character that isn't one of the braces. So this allows nested comments so that you can comment out a whole piece of IXML without having to worry about there being comments in it. So in other words, comments can have nested comments, but the reason for that is so that you can comment out a whole piece of IXML. Most of the other rules in the IXML grammar are fairly self-explanatory, but there are a couple that are worth looking at. A string, for instance, is one or more dchars, whatever a dchar is, enclosed by double quotes. And similarly for a string with single quotes is one or more single characters. There's no such thing as an empty string in IXML. There has to be always at least one character. So a dchar is any character except a double quote or a new line. Strings are not allowed to extend over a new line. Or two double quotes. So here you've got the definition of dchar. It's any character except a double quote or a carriage return line feed, or two double quotes. And since two double quotes in a string represents a single double quote, then one of those gets deleted and one of them doesn't in the output. And schar is just the same, but then for single character, for single quotes. A literal is either a string or a hex encoding, so it's quoted or encoded. Quoted is a mark followed by a string, and encoded is a mark followed by a hash followed by a hex value. And string and hex are both attributes, and so they get moved up, as it were, so that they appear on the literal as an attribute. So you either get, so for just this quote A quote, you get literal string equals A, and for hash A, you get literal hex equals A. And if they have a mark, the T mark appears there as well, because that's also an attribute. Hex encodings are treated slightly differently in character sets, which appear as serialization as either an inclusion or an exclusion containing a series of members. So, for instance, this value here can contain string A or hash A, or a range A to Z, or a range hash A to quote A, is a member string equals A member hex equals A member from equals A to Z, or a member from equals hash A to A. So for a range, hex values are treated slightly differently. Rather than having a different attribute for hexadecimal range values, you just tell the difference by the existence of the first character being a hash. In other words, a from that doesn't consist of just a single character, but consists of a hash followed by a character, is a hexadecimal value. So in that one case, the hash is not deleted. All right, so I'm finished very, very early. So those were all my example case studies. Any questions? Any comments? Any? Yes. Are we being broadcast? I'm not sure if we are. Just in case we are, let me just.
Thank you. All right, now we've seen from a text grammar going to an XML. What if I want to go the other way around? Is it possible also to create an XSLT script that kind of gets back the original content?
So, in fact, I presented exactly that issue, I think, at one of these conferences, maybe it was 2 years ago. So go to the XML Prague from 2 years ago, and it's called round tripping, and it shows you how to do exactly that. Were you not at my talk yesterday?
Yes, I was.
Okay, so round tripping, what that does is it takes an existing grammar, any of those grammars I presented there, and transforms that into a grammar that recognizes the output, the XML in other words, and then outputs that as just text. So you can round trip it.
Okay. So
you won't get an identical document because you might have deleted some stuff in the input that you can't recreate on the output.
So you round trip with XML, with IXML again, and not via XSLT.
With IXML, exactly. Yeah. And it's actually quite fun. I mean, writing that paper, I discovered that if you transform the grammar twice, then you can go from the original to XML again in the same way. It's quite fun.
It's really clever. It's like watching it. It's very cool.
I'm actually gobstruck. I mean, I thought it must be possible, so I tried it out and wrote the paper, and I was gobstruck by the result as well. Yeah. Any other questions? Yes.
You presented the assembly-like structure, and is it possible to define it in a recursive way to get all the nested elements?
XML is recursive.
Yeah. Because you have defined R1, R2, R3, and so on.
Well, I mean, you had if the language that you're trying to recognize is context-free, then you can just use regular recursion. But the fact that it was not context-free means that you have to have those separate rules for R1, R2, R3 to represent the nesting. But if it were bracketed, for instance, so if there were really just brackets around the nested thing, then you could just write one rule that worked recursively, and that wouldn't be a problem. So the problem in that case is just the bad design of the input format. But at least we can deal with it to some depth. I mean, a similar thing that is Python. Python's not context-free, and so you can only represent the nesting of Python to a certain depth because it's represented by indentation, and there's no explicit marker to say this is the end of the indentation. That's just the fact that it's got smaller, but you can't represent that in a context-free grammar. All right, well, you're excused. You've got a half an hour extra coffee break. Oh, yeah, oh, no, sorry, another question? Right, coming up.
Well, if I have you here, then I use the time. In other parsers, especially the LL and LR parsing, there we have the possibility to have separate modes. So to say, in one mode I use these rules, and then I switch to a different mode where I use this slightly different rules and different character recognition. Is that something that you have considered as well?
No, we haven't considered that. If you think that that's useful and there are good use cases, then please submit some examples to the group, and we'll consider it. But
okay.
we haven't.
Just when doing CSS, for example. But yeah.
Yeah. Okay.
Or come to the meetings and talk to
Or come to the meetings. Yeah. The meetings are on Tuesday afternoon, European time, for an hour every second week. And you're more than well. You have to join the group because then you have to promise something about IP. But you're more than welcome to come to the meeting. Okay, class dismissed.
it here. So how it goes, I need to switch. Oh, that would be nice. Yeah, I have a second one. Někde jsem ho viděl, někde venku nebo... Now we can connect to WhatsApp because other people forward this Okay, so I will switch back to the computer with the scale because there will be, before there will be some control, but I think that was a couple of minutes. Open a copy from that conference and I will do it. Yeah, I will put, oh, you can, I can put it on you right now. Someone just made some note here. For another round of sessions. I hope you enjoyed the dinner yesterday and all the music, and also the morning tutorials. And we will start with the regular session. But before that, I would like to give place to Sheila from Saxonica, and she will tell something about Saxonica and why they are sponsoring XML Prague.
Thank you. Yes, so I'm the newest member of the team at Saxonica, and so I'm the sacrificial lamb this morning. So we're all attending, one of us in person, but we're all attending because we really value this event and the community around it, and see it as a fantastic opportunity to meet people, to have discussions, to swap ideas and to learn. And that is essentially why we sponsor the event, is just because it's just a fantastic opportunity and community. So thank you everyone for being here. And thank you, Jirka and Mohammed, for organising it.
And thank you for sponsoring. And not only me and Mohammed, it's also attendees and other folks. And there is, Boris, come here. And there is another long-term supporter of XML Prague, Boris.
Yeah, thank you. This year I represent Czech Association of Digital Humanities that sponsored this event. Thank you all our organizers and speakers, presenters. You are here, you share your knowledge, your tools. And with us, Czech Association for Digital Humanities is a group of 30 people here in Czech Republic that use your tools. And for example, one of our member, Dr. Professor Heitch from Charles University, now leads a project that builds language models for European languages. So I hope you will benefit from it too. Thank you. And see you in next year or next 2 years. Thank you very much.
Thank you, and definitely see you. And there is quite interesting event after the weekend in Prague as well, Digital Publishing Summit, and we are glad that the Gautier Schummel will tell you something about this event and other stuff he's doing, so please go on.
Thank you. And thank you for being here. So I want today to take you inside what we do at IDEA Lab. So IDEA Lab is the European Digital Reading Laboratory. I will enter in more detail, but before I want to take some time to put some context and some reminders about how XML interacts with the publishing industry. I want to start with a very simple idea that publishing and XML have long had very productive relationships. Scholarly and technical publishers were early adopters. They have used XML extensively. Most of you probably are deep into those operations. And that's for good reasons. One source can produce many formats, the workflow becomes more cost efficient, and the content is easier to keep future-proof and discoverable. That logic is still powerful today. If you can create content once and reuse it across channel, devices, and use cases, you reduce duplication and preserve consistency. For publishers, managing complex content, that is not just convenient, that's strategic. But XML also has a downside, because most professionals and readers never see it. That makes it a form of invisible infrastructure. And as often, invisible infrastructure is underestimated. Because it operates behind the scene, it can seem abstract. It's a matter of experts that only specialists understand. And that combined with a paper industry, because publishing remains a paper industry, and short-term production pressure that make tempting to treat XML as a purely internal format. And the decision made in that layer directly impacts what reader can do later. But the truth is that XML not only serves the workflow, it also powers digital reading. The experiences we can have to read with eyes, ears, and fingers. In other words, it's not just about producing file efficiently, it's also about enabling reading in the broad sense. Visual reading, audiobooks, navigation in a book, let me also mention annotations, using a book, reflowable, accessibility, and interactions. So a good example is EPUB. If you do XML plus zip, then you get an EPUB. If you do XML plus HTML, then you get an XHTML. We have two specific namespaces, the OPF and the OPS. And these are not just file format details. They are part of the way digital books become readable, portable, and structured. The namespace and package structure exist for a reason. That helps reading system understand what is the book and how it should behave. So what happened? What does the reading system do? Typically, the reading system will first read the MIME type to confirm that file is an EPUB. Then it will parses the container XML to locate the OPF file location. And that will give him a lot of information about discoverability that will allow the reading system to display book information panel that will allow to display the table of content navigation, navigation by page, maybe landscape, if you have authored a rich navigation featured EPUB. Then it renders content from the manifest spine, and that content is published as XHTML. So we can leverage specific semantics for navigation and rendering. So a word about HTML. The short message is, keep it in the XML flavor. That may sound playful, but it reflects an important requirement: stability, predictability, and fidelity that matter in electronic publication. That happened because books have long lifetime. Older books need to be available to be read in a good experience in newer reading system. And newer book must still work on older systems. Not all e-reader manufacturers choose to deprecate the use of their dispositive. We have e-readers that are robust materials and that are available and used for reading even after 10 or 15 years. That's a difficult requirement, and this is one reason why changing the toolchain would never be trivial. Retooling means investment, migration effort, and an adaptation period. Last year, there was an EPUB and HTML survey produced by the Publishing Maintenance Working Group at W3C. And the short answer was, please keep the XML syntax. We need it. If we don't keep it, we will break workflows, and that will not help the e-books having a better reputation than what they have today. This is where the W3C publishing community groups comes in. This group is open to anyone. Yeah, probably the mic. Thank you. So this group is open to Zine1. You only need a free Directory account, and we meet monthly plenaries on the fourth Thursday at 5 p.m. UTC. I'm co-chairing this group with Wolfgang, who is my co-chair colleague and who is with us also today. We work on topics that are very relevant to the industry. How can we simplify multiple rendition workflow? Let's say I want to have my book in a reflowable on the fixed layout version. I want to have my book in an audio and a textual version, and maybe even with some video version. Let's say if I want to have my book produced in sign language. Okay, I'll try not.
Your badges, yeah, it will be better. The problem was different. It's solved now, I suppose.
Thank you, and sorry for that. So we are working on simplifying multiple rendition, on LLMs in reading system, what can be done, what should not be done, what should be the caution to take. We also discuss about that's the next subject, the incoming subject for the end of this month. AI preference, what publishers really need to indicate what an LLM can do with the ebooks. And we'll also have a discussion about language tagging issues, which is a complex topic. So the group is open. We really need everyone working in publishing with technical capacities, competencies, to be with us and to help us shape the future on that. Sorry. Now, let's bring this back to IDEA Lab. So we are building an open, interoperable, and accessible digital publishing infrastructure for text, audio, and image. First, we are a non-profit laboratory. And then we are a membership association. Our mission is not only to define ideas, but to provide concrete building blocks also. We have 119 members in 45 countries, and we provide standards, toolkits, software, and knowledge. First example are the Radium toolkits. So those are open source toolkits. You can find them on GitHub. They allow you to build your apps with ready-made components for all your needs. We have a CLI, a server tool that allows you to process an incoming EPUB or audiobook, even a PDF, to prepare it to be easier to read in a component like a web reader, but we also have Swift and Kotlin that today powers, we think, at least 100 applications. It's open source, so we don't exactly know how many applications are built on our toolkits. But yeah, we have heard at least of 100. So that reduces burden and maintenance on development teams, so they can focus on their product. That also helps smaller structures to climb into the universe of digital reading. And let's say a library can build a reading application quite easily and for a much lower cost than if it has to build everything from scratch. My second example is Thorium Reader. So this one is an application. It's actually available on Mac OS, on Windows, on Linux, on iOS and iPad OS. It's a digital bookshelf where you can store and read your ebooks, comics and mangas, audiobooks also. You have all features, color, spacing, design the reading experience that fits your need. You can read any book that you've been reading online, but you can also use the application to borrow an audiobook at your public library or download a chapter of your favorite manga, etc. Everything is, every reading experience is possible here. And I will do a demo just after, so you have a better view. That's on the reading side, but before reading, you need to access your contents, and as publishers, you need to have some tools for content management. So first, you do ebooks, so you probably want to have some protection, and we all know the bad experience that we had with digital right management systems. We provide LCP, which is licensed content protection. It's a frictionless and privacy by design, so you only get a passphrase. You don't have to create an account, and that means that no one knows what you are reading. Of course, it can be tied to your library account or to your bookseller account or even to a publisher account. But there's no third party managing the DRM who knows anything about what you are doing with your ebooks. LCP was requested at first by publishers and by publishing association because the existing DRMs were costly and ineffective. So we tried to make it economic and performant. So first it's managed by a non-profit association, and then we every 2 years to make sure that it remains robust. Secondly, you have your file protected and you want to distribute it, so you want it to be displayed as a catalog, and you want your collection to be available in as many places as possible. That's what the Open Publication Distribution Standard, OPDS, allows. You can have discovery, curation, filtering, and lending, and that can happen on a web page or in a reading application. And by a reading application, that could be Sorium Reader, that's the demo I will be doing, but that could also be an e-reader. Some e-reader manufacturers already accept OPDS and already accept LCP. That's the moment I will try the demo. So this is Sorium Reader. Just have to, okay. And first, a very new thing, we have no profile. That means that any library or any bookseller, even any publisher, could easily build his profile, add it in Sorium with a very, very small fee, or maybe that will even be offered for IDEALAB members, I guess. With the profile, you can shape the experience you want, and you can log into a library. You have some information, and there you have catalogs, even your FAQ, your demo reader, etc. I will remain with the vanilla version here, and I will go to catalogs. So here I can add any catalogs. For now, it's a bit complex. You have to add the feed by yourself. You have to know, but you can add here the feeds from archive.org, from gutenberg.org, from Gallica. We don't have Europeana yet. I will use Lirtuel, which is a Belgian library. So I'm inside the catalog here. I have curated resources, and I can even perform a search here. I want a book about book. Up. Let's try this one. So here I have all my book information, including accessibility information. Then I can borrow the publication. And here I'm connected to Virtual, so it will not even ask me the passphrase. I've started my loan since June 6. I can read it until July 6. I can import the EPUB. And depending on my connection, okay, it's done. Okay. Then I can read here. While the size of the screen make it a bit tricky, I have a lot of options. Now an option here for adjusting the reading experience. I have table of contents, landmarks, and pages, and I can use annotations here that will become part of my navigation. I can export and import annotation if I want to change from one reading system to another, or maybe if I want to use, I don't know, what the teacher sent us as annotation. So that's it. Very simple, very easy workflow, and all that is open source. So I showed you what we have. We use it for demo. But you can easily build your own version of Thorium. You can easily build your PDS. And we are happy to discuss anything that helps you operating with those technologies. Last but not least, at IDEA Lab, we think that the ecosystem comes with standards, with building blocks, applications, but also with knowledge. So we have a yearly Nomad conference, which is a Digital Publishing Summit. It brings experts from all over the world to shape the future of digital reading. We also, and that one will be in Prague on Monday and Tuesday. Then it will be followed up by thinkpub.eu, which is a European network of conference, and also an online library. This one is less technical. It's more for stakeholders and understanding the changes that are going on in publishing. Then we have a Regium Dev Day, which is the Regium technical meeting to discuss best practice. That will be your first Regium Dev Day this year in Prague. So the idea is to have a place for developers to discuss together and to have club mate. Then we have members circle, which those one are strictly restricted to our members that provide monthly insight designed to keep our members at the cutting edge of technical standards, accessibility regulation, and software evolution. That's all I wanted to tell you. I'm open if you have any question or any comment on all that.
So, was it a question?
Thank you very much. So I was wondering, with Thorium, is there at the moment any localization for the interface settings? I mean, you had them in English, but I'm not sure whether you did that because we're probably not all. Whether you did that because the conference language is English is what I'm trying to say. Apparently, I can't speak English either. Or whether there are other things, and do you accept pull requests for localizations?
So we have localization, and we have it in Czech. Where is it? It's here. Up. We have a set of localization that are mainly provided by your members. We accept GitHub pull requests, but now we try to use a management system. It's Weblate that helps non-tech people or less tech people to enter the workflow and be able to provide translations. And yes, that's localization. I mean, that's not machine powered. That's real people that are thinking about how the bookish thing is spoken in their language and in their country. Welcome.
So, some more questions? It's hard to see in front of the lights.
So can it be connected to a particular publisher's or distributor's system, for instance, Kobo?
So Kobo is a very recent member of IDEA Lab, and we are working with them, so the LCP protected files will be readable in the device, and you will be able to export what you've been reading in what you've been buying with Kobo, and read it outside of the Kobo ecosystem and using those tools. And we also have discussion with Kobo about the implementation of OPDS, but it's a larger discussion.
So is that does that come under profiles, or how does that happen?
The profiles are just a little set. It's a JSON file with some resources that you shape it, you send it to us, we validate. I think we have to apply a small fee to validate that. Or maybe it will be free for our members. And then we input it in Solium Reader, and then you go to profile, and you can get your profile directly. So that's very convenient for university libraries, for example, because that means they don't have to build anything. They just have to be member of IDEA Lab and have a small profile, and then the students download IDEA Solium Reader. They choose the profile of the library. They get an authentication screen, so they can log in, and then they have access to all the collections directly in the application without need to go back and forth with the websites.
Is there any other question? So I have one question. What about some really large publishers who are kind of dominant on the market? So are they going to support those distribution standards like some Amazon and others? So do you have some cooperation with them, or they are completely outside of this standardization effort?
So LCP and OPDS are today discussed with Kobo. We don't have open discussion with Amazon, so it remains part. But the point is that we try to build an infrastructure that frees you from silos. So that means that you should be able to do everything you do on a Kindle or on a Kobo without having to be Kobo or Kindle guy.
Okay, thank you. So thank you again.
Many thanks.
It will automatically run all the XSpec that's in that repository, and it won't let you merge the pull request in until your tests pass or are marked as pending. But theoretically, all the tests would pass. So unit tests, I think we're doing quite well. But unit tests on their own aren't enough. A unit test is very good at saying what you want to change and making sure that that change works in isolation. But if you change something that you don't realize, if there's a knock-on effect, if there is a product with a slightly different requirement that you haven't taken into account, and that breaks, you want to know about it. And for that, we really need regression testing. And there isn't a standard for automated regression standard testing in XPrague. Very recently, we have some support for XPrague unit tests with XSpec version 4. So thanks very much to Amanda Galtman for that, and that's something that we'll definitely be looking at starting to use. It is a bit limited. It's currently, I believe, only limited to Calabash. Our infrastructure at the moment uses Morgana for the XPrague. When I first had this idea, I did make sure that I went and spoke to Amanda, because I wanted to make sure that A, I wasn't stepping on anybody's toes, and B, I wasn't needlessly doing work that I didn't have to, because as anybody who knows me knows, that's not something I'm a fan of doing. And we agreed that actually what we're talking about with regression testing is a different use case. Much more about what's on the file system, not necessarily the abstract idea, and much more end-to-end testing. So I'd implemented all of this automated testing, and I thought I'd done a good job, and I thought it would be okay. I had quite a complex requirement come in that involved changing one of the big migration scripts, and I submitted it to my manager at the time. Mark said, "Oh no, it breaks such and such." It breaks. I don't know. Why didn't I know this? I thought, what have I missed? So it turns out that Mark was running the regression tests locally on his own machine, using a corpus of data that he'd built up as he'd written these scripts over the last 5 to 10 years, in collaboration with one of our suppliers who we'd actually inherited a large part of the code base from. And that was the process for testing this script. Mark was the owner of the script, and he was running these tests manually, and he had an idea of what to look out for. Who knows whether that was comprehensive or not, but he would do a manual diff of the files, and he'd have a look at things. And I didn't think that was good enough. I didn't think that it was fair to rely on Mark to do all of that work, although he's very reliable. Mark left OUP last month to go and do a different gig, much to all of our distress, because he was an excellent manager. And whilst he could be trusted to know what to look for, I wasn't convinced that I could be after he left. So, and it's hard, you know, because we're often talking about some very deep file structures, archives, and as I said, nested archives. These aren't easy things to compare. You have to do a lot of manual work if you're doing it yourself. You have to go into folders, you have to unzip folders. You might have very similar structures, and it sounds ridiculous, but it could be quite easy to compare the wrong file to the wrong file, potentially. So yeah, it's difficult on the human level. The other thing is that you have to know what to ignore, and I think this is a large part of why Mark was still doing it manually, because all of our transformation scripts include comments that tell you when they were changed. So if you look at a directory level diff, every file will be different. And there's a lot of this non-deterministic data that will change from one transform to another. Timestamps are the obvious one, generated unique IDs are another. And if we're talking about the general case, there could be all sorts of randomly generated stuff in your files, which you need to know what to be able to ignore. So, the impact was that none of this was ever automated. It was manual testing. The scripts are quite fragile. It's not obvious to the developer what needs to change. And we don't have the automation that we need to actually ensure that these things are being checked as soon as possible so that they can be fixed whilst you're working on the same code. You don't have any context switching problems, going away, working on something else, and then forgetting what you did. There's no shared approach, either within the team, because there's no formal way of doing this, but also more widely amongst ourselves, the people who are here and the people who aren't. And you can imagine as more and more products get added to these scripts, as we have to do this regression testing across a whole ecostructure of transformations, it's going to involve more and more work. It's not very scalable. So, me having very little experience of automated regression testing thought, well, let's fix this, right? This should be easy. Let's build a regression testing library, and maybe I'll get to go to XML Prague on the back of it and talk to people. You know, how hard could it be? What could possibly go wrong? I finally got this working yesterday morning at 1 o'clock. The answer is, it can be quite hard and more complicated than you thought. So the idea was, let's have a portable regression testing library. Let's make sure it works on Calabash and Morgana. And hopefully, it will continue to work if any other XProc implementations pop up. And so we are restricted to the standard step library plus a few steps from the file optional step library, which both Morgana and XProc support. I wanted to make it open source, which was very interesting because I don't think, certainly not my team at OUP, but I don't think OUP has actually published any open source software until now. So initially, I was emailing people saying, do you fancy starting a project that I could contribute to? But everyone was a bit busy. But that's happened. I've cleared it with legal and with cyber security. And the library is available, and we'll have this slide again at the end, on GitHub. So let's talk about some of the key ideas. The first key idea is we have to compare two different outputs. At the moment, it's very much restricted to outputs on the file system. That might change. We have to look across relative directory structures in both those places. Again, perhaps I needed to put something in a different order for these slides. Bear with me. My approach to this, and again, we have files within archives and files within archives within archives. We only go 2 layers deep, but in theory, you could imagine it being more recursive than that. So rather than compare things directly, my idea was, let's build a manifest. Let's build a file that can record this information, the file structures in the folders, the file structures in the recursive archives. We can pull out some file metadata like the size of files, but that's probably not good enough. We can also support hashing of files in this manifest so that we have a way of comparing that these files are more or less even, more or less the same. However, we can't just hash the files as they are on the disk because of that non-deterministic data that we were talking about. So this is my favorite word, and for some reason I have chosen to put it in my paper and my presentation multiple times. Canonicalization, in this context, means handling that non-deterministic data in a way and making it deterministic. So it's not the same thing as XML canonicalization, but it's a way of sort of standardizing some of this data so that we can compare it. And that's a tricky challenge, right? Because, well, that went very loud all of a sudden. I don't know what you need to standardize in your data. And if I want this to be a library that you can use as well as one I can use, I need to let you choose. So we need to be able to configure this potentially per test, certainly per test configuration. And I need to let you run your own XProc step, which will do this canonicalization. I want to have tests that are declarative. So I want the test definition not to be written as part of the executable XProc code. I want to have a standoff config file that defines my texts. I don't think this is a particularly difficult concept for the people in this room. So there is, for the declarative tests as part of this library, an XML config with its own model in RelaxNG. You can have a look at it on the GitHub repository. It defines inputs and options for each test that go into your pipeline. Obviously, it also defines which pipeline you want to run. It reuses a lot of the models from with input and with option to do that, so that I can very easily turn them into XProc later and pass it in. And it also stores some manifest information. This is perhaps where I ought to go back to my slide about what regression testing is. The idea is that you have some input documents. It'll go through some process, in this case, an XProc step. It'll produce an output. And at some point, we decide what output it should be producing. We might start off by creating it by hand, or edit it by hand, or we might run it through once and say, okay, this is our standard, and that's called a baseline. That's what I'm referring to as a baseline. So you have your baseline. You say this is what this should produce, given this input, expect this output. You make a change to the process, rerun the input, so you get the output out, and then you compare the two to give you your result. So we have manifests. If we're doing this comparison using manifests, we need to have a manifest for the baseline, and we need to have a manifest for the output. There's no value in storing the manifest for the output, because that will change every time you change the script. The baseline changes less often, so we store that, and we can cache that either in the test. Where are we? Either in the test config itself or as a referenced file. I wanted to use the standard suffix of .bmx, but apparently that already means something else. So those are the concepts, those are the ideas. In terms of actually implementing it as a solution, this is the architecture we've ended up in. We have to, so we provide an XProc library file, which is your starting point. You feed your config file into that, and it produces another XProc library. In fact, it replicates a lot of itself into this XProc library, which is what I'm calling a test harness. When what you want the output to be changes, when you want to change your baseline, and obviously this includes the first time that you run the test, you're going to need to create those baseline manifests. So your test harness actually will do that, will create your manifest saying what you're expecting, and that's saved back into the config file. Then you can run your actual tests. That will create your outputs, and it will create manifests of your outputs. Then it will do the comparison and generate a report. So it wasn't originally my intention to have a generated code, this sort of two-step process. I thought that I'd be able to do it in a single step. Again, I was really taking the lead from what XProc does when I realized that that wasn't going to be possible. And it's not possible because XProc doesn't really have a way of overriding step definitions. So there's no way of saying, for instance, for your canonicalization, what particular form of canonicalization you need for a particular test. I wish I'd call it standardization. I could say that so much more easily. You also, in terms of dynamic evaluation of XProc, we've got this step prun, which is an optional step. Calabash supports it. Morgana is only supported in the paid version. And I wanted to make sure that this was a tool that was available for all users of XProc, not just the people who were paying for it. So what we actually have to do is to generate the test, the test harness. That needs to be regenerated every time your test definitions change, so that we can actually create XProc that explicitly runs the tests, the steps for your test. And that means we can avoid having to do the sort of dynamic evaluations altogether. And it also means that what we're producing should be standard XProc and, touch wood, should run on both versions of Calabash and Morgana. And if they don't, Norm and Achim are both extremely responsive and very helpful. Okay. The results from this at the moment, I've got it working with a very simple JUnit because my priority is the automated continuous integration testing. But that JUnit is not particularly helpful as an output. It's a pass or fail for each test definition. I want to do a lot more that's actually going to be helpful for developers. So human readable diffs. That's work in progress. I'm perhaps being generous to myself because I've not started yet. But it's planned. And that will actually produce an HTML report with some side-by-side diffs, not just of the manifests, but saying what in those files might be different. But you know, for an early beta, which is kind of the stage we're at, JUnit is good enough. It says something is wrong, and then you can go and find out what that is. There are some other areas as well where things could definitely be improved. So for instance, at the moment, the manifest comparison is just doing a deep equal. That means if you pretty print one of your manifests, it's going to give you a false negative. So, you know, it's still early days, but it's working. How am I doing? Perfect. What's next? Well, I don't want this to be a tool that I've created purely for my own use. I want to collaborate with people. So I invite you to have a go, have a try out. I've already mentioned I'm planning to have better reporting. At the moment, we are only testing file outputs that you say in your test configuration where you should go and find the results of the step. But actually, we might want to be able to do tests with the output ports of your XProc. And we should be able to support that somehow. We might want to be able to have tests that we want to fail. We might want to have tests that we need to test should throw errors. Things like that are all work that's to be done. And it all relies on on the community effort with it, I think. Because the other thing that we really need is to make sure that this is in use and tested, and by doing so that we can be sure that it's actually meeting the needs of the XProc using community. So I'd encourage you to go and have a look. That's another link to the GitHub repository for it. Yeah, XProc baseline is the name. Are there any questions? Thank you.
There will be questions because we have plenty of time, so.
I haven't done a demo because it's very boring to watch, but that's a possibility. If you want to see it, come and see me in a break.
Hi, thank you very much. And my apologies for the pure ignorance. So it's open source, the code is out there, but I haven't had time to look at it. So can you elaborate a bit on, in browser land, we would call this visual regression testing? So think of, I don't know, tables or charts in some print product. This kind of pixel comparison, is that something that, a direction you want to go in when you talk about diffing, or is this currently more, you know, the XML files?
I think it's more about the XML files for me at the moment. But if that's a direction that would be beneficial, then it's open source and it would be great to explore that. I think it would be further down the roadmap than we are. It's a bit over the horizon perhaps, but yeah, why not? Norm?
Yeah, thanks, Tom. You asked me a while ago to think about override in XProc, and I haven't yet, so apologies for that. How much thought have you given to what you want to do instead of deep equal? I'll make a couple of observations. Both the Qt3 test suites and the XProc test suite essentially allow the test author to write a set of assertions that have to be true. And I think that that direction might be better for you in the long run than deep equal.
Yeah, I think that's true. I think my proviso is that regression testing is about testing the things you haven't thought to write a test for. And if you're putting that effort into writing assertions, you're filtering what you're looking to compare, and you have to be careful when you do that. That's kind of what the canonicalization does. So I think that it might be true that you want to filter down and do assertions for some things, but you probably also want to have at least some tests which are testing the whole output. What counts as important and what counts as not important? In terms of the content of your actual results, canonicalization you've got a good level of control over. The deep equals is about comparing the manifest files that we produce. So I think that probably requires less fine-tuning control. But I'm interested in some of the pairwise streaming tools that are available now in XSL in version 3 and 4. This is based on version 3 because version 4 is not released yet. So maybe something like that in the future both to do a comparison, but also the HTML reporting is going to have to be a lot more sophisticated than I've had a chance to make it. Does that answer questions?
One more question? Yeah. Hi, Tom, thanks. Can you, the word is great, canonicalization. Is that correct? Can you elaborate a little bit what types of canonicalization you perform actually, or you plan to perform in your workflow?
Sure. So the canonicalization steps that I have, I can maybe even show you some. There are a couple that I've implemented. Extremely simple. What happens is when you're creating the manifest and you're creating the hash for a file, before it pulls that data out, it will do an XProc step. In this case, I'm running XSLT because that's what I do. And in this case, it's...
Thomas, you are not projecting the same thing.
Damn it. Choose mirror. I thought I did this already. It's not mirroring. It's because I'm in presentation mode. This is why. So how do I end the show? There you go. Escape, what is this keyboard nonsense? Yeah, I'm a Mac user, I have to do everything with a mouse. Yeah, so in this case, I'm simply replacing things that match as a date. I'm sorry, Stephen, I thought about using invisible XML for this, and I decided not to. So anything that matches a date stamp, and I'm just replacing it with a standardized date stamp. So that then internally in XProc becomes the representation of the file, and that's what we hash. And then you do the same thing with the output of the actual test.
So thank you.
Is it mainly ignore? Some kind of ignoring? Is it some kind of ignoring in the deep copy? The big one?
It's ignoring by turning them into the same thing.
Yeah.
Yeah.
Okay.
So thank you again.
Thank you very much.
Connect this thing up and let's get going. Oh, let's not jump to the end. And avoid spilling a large bottle of water on my computer. Right, hello. My name is Matt Patterson. I work for Saxonica, but this is not a Saxonica project, so that's why it doesn't say Saxonica there. This was the title I pitched in my abstract. As with many things, I used the process of pitching a talk as a forcing function to make me actually do some work. So I may have oversold it a little, and it's kind of interactive web experience might be pushing it. But there's a lot of Word manuscripts, and there is a website. So the project I'm going to talk about began a very long time ago, back in 2011, with a call from a collaborator of mine who was talking to a guy called Jerry Cinnamon about an unpublished... Let's try that again. Is that okay?
I will use more textile.
Okay. Yeah, great. Jerry had written a biographical dictionary, which I'll talk about in a second, but it wasn't published. Jerry Cinnamon is a significant figure in British post-war graphic design. He was the chief designer of Penguin for a number of years, and went on to become a very well-respected historian of the field. So I was intrigued by this idea of an unpublished Jerry Cinnamon manuscript, not least because Jerry was my external examiner for my BA in typography at Reading. He conducted my Viva and was moderately terrifying. The book was still in manuscript form, and the manuscript was Word documents. And one of the things we're talking about, what will we do with this? And what would be the best way of getting this out there? And we thought, well, a website. Now, if you've read my abstract, you'll know that this is what this is about. But what he'd written was a biographical dictionary, basically about the designers, the kind of mid-20th century designers who didn't emigrate during the Nazi regime. There's a whole load of people in here. Some names you would recognize, some you wouldn't. And it has 700 and something entries, some of which are a single sentence, some of which are almost a small book in their own right. I don't have a huge amount of time, so I'm going to go fairly quickly through the various stages of this, but if anyone wants to look at this is live on the web. You can look at it now. So the manuscript looked like this. It's a Word file. In fact, it was written long enough ago that these were .doc files, not even .docx files. So the place you have to start is, well, what's in here in terms of structure? How do we get it out? Obviously, it was typeset impeccably, but there weren't really any actual paragraph styles or character styles in the document at all. And paragraph styles and character styles applied consistently are basically the only lever you have inside a Word file. So a lot of the work in this project was just figuring out what set of styles would allow us to capture the structure that was kind of implied by the visual presentation and some of the richer stuff. And but that also wasn't too onerous to apply, because if it takes you an hour to do, a very small entry, then you're never going to make it through the, hundreds of thousands of words of text in this book. So once we'd figured out something that was a fairly reasonable compromise, and there's a lot more about this in the paper. I'm going to be saying that a lot because there's a lot more in the paper that goes along with this. We basically paid someone to do the actual work of applying it. And so this is kind of what we ended up with. One of the great things about marking up a manuscript that you're never going to try and print is that you can do things that are unprintable to make things easy to understand. So we had a set of styles, and we could color code things. So as you're kind of keyboarding your way through, because you could do all this basically without your hands leaving the keyboard, you can see what you've done, and you get a fairly decent idea about whether you've done it correctly. Obviously, if you've ever done any stuff with Word and you haven't come across the styles pane is absolutely key to doing this kind of work. You can still get to it. You can get to it from the weird home ribbon thing, and it is great for this kind of work. So some more stuff at the end, so you can see where we're dealing with bibliographical entries inside the biographical entry. Obviously, dealing with a Word document is even one that's been well styled, is not super pleasant. This is a Word file. Obviously, modern Word documents are just a collection of XML files and stuff shoved in a zip file, 3 kids in a trench coat. This is the main document XML file. Pay close attention to the line numbering. There's only one line. Two if you count the XML declaration, but let's just say that white space is significant. But in essence, it's just a flat sequence of paragraphs. That's what it kind of looks like if you explode it a little bit. And each paragraph contains metadata about itself and its text that's in a container. And actually, that container it's a set of runs of text that can also contain metadata and can be interrupted by all sorts of stuff. So the way that the Word tracks stuff like spelling mistakes is it puts in empty markers to mark the beginning and end of things, because it can't do overlapping markup. It can't even do nested styles. It's just one at a time. There's an awful lot of XML space preserve attributes in a Word document. Ignore that at your peril. As I said, you can put metadata in the runs of text, and that will tell you what character style is in effect. The same way you can do that for the paragraph. So this is basically what you've got to imply structure for our dictionary entries. So that could kind of work. It looks like those are something we can work with, but how do we get actual explicit structure from the implied structure? So, I mean, these are XLT2 techniques, and they work great, provided your inputs are the correct kind of regular. And as I say, the deal with styling that XML, styling the Word documents, is that you try to make sure that your document is the right kind of document. So more than just splitting up those inputs into entries, we also need all the extra stuff we need to construct the site. So a site looks a bit like this. There's an A to Z index of the designers, and we need to know who's next and who came before. So that's actually the first entry alphabetically. So we've got a link to the next entry, so you can traverse through that way. And we need that kind of information as well. So the index itself looks like this is the bottom of the index. It's quite a long way down from the top of the index. So it's a sorted A to Z list of entries, one list per letter, although if you look carefully, it's actually three lists in a trench coat. It's three. When I originally wrote this, CSS multicolumn wasn't a thing, and I haven't tried to rework that aspect of it. Because the original version of this site goes back, more than a decade. So that's actually three lists side by side, which we'll talk a bit more about later. But it's kind of conceptually one list. Dictionary entries have a subject. The subject has a name, and we need to generate a sort name for them so that we can sort the list appropriately. Subjects can also have a number of aliases, which also need an index entry. So some people have an awful lot of other names they go by, or little nicknames and things in there. And we need to reconcile all the input files, because the manuscript wasn't one manuscript, it was 7 Word documents, and it was split because if you didn't split it, your Word would crash. At least Word circa 2000 would crash, which is when it was written. So we've got a whole set of files. We need to be able to reconcile things between them, because the first entry here will, its previous entry will be maybe in a different file over here. And that's quite complicated. So we need an index, and we can use result document to get things out. So here's a kind of, we'll look at some of these parts of the template in more detail as we go through, but it's all in the paper. So some way of turning things into chunking it up into entries, and then we generate index entries. So we generate chunks for the A to Z index as maps, because we're going to output that as JSON. And then this style sheet outputs JSON, and we generate the XML for the entries with XSL result document. And we do kind of, the clever part of this is that it's fairly simple. And we do that using XSL iterate. So effectively, we are constructing the index entries, handling the next and previous parts by using XSL next iteration to generate the map that we then pass to the next pass-through, so that we can then add the next entry into that, and at the end that we end up with a complete map. Yeah, it's an XML conference. Why am I talking about JSON? So this is the JSON index that we wind up generating. So we've got a URL slug for the eventual HTML we're going to generate, name, sort name, and here another entry that has name, sort name, and some aliases. Well, an alias in this case, with again name, sort name. And the first thing you need to do is chunk your Word document up into separate entries. So we've got that list, and as we saw, we can use the presence of what is effectively the A head as a indicator that we've started a new entry. So we can use for each group and group starting with, and that's what we're doing here. So we're getting the style name out and using that to key on. The nice thing about doing this in a function is that it makes the initial call to XSL iterate lovely and straightforward. We don't have to have a gigantic something or other around that to give us things. We can just get a simple sequence out by doing this. And then once we've got that wrapped entry, we can do another round of applied templates to do all the grouping within that entry. And once we've got a final entry, then we actually generate the URL slug that we're going to need for that and add it in. And then once we've got that, that's how we can generate the JSON index entry with a URL slug, is we can take it from the thing we've just done. So this is how we make those things up, and this is all fairly straightforward XPath 3 kind of stuff, but it's very easy to generate. So we have a function that generates the name and sort name map, and then we have a function that generates the index entry for a whole subject. And so that can use a subject name function to generate the right map for the main entry, the main part of that, and on any aliases that there are, which we just output at the end with this XSL map. So XSL map will just, basically you're passing it a sequence of maps, and it will just merge them all together to give you a final map. So we have the first map, which is just the name and sort name for the main subject entry, and then we have an aliases map, if there are any aliases. So now we've done enough stuff to get an entry out, but what about pages? So here's the entry for Otel Ica. This is one of the larger entries. He has an awful lot of, he did a lot of stuff, and there's a lot of stuff that he wrote and a lot of stuff written about him. Someone with some aliases. Someone with more aliases. So we need names, the text, lists for the bibliographical items, cross-referencing. So other designers get mentioned in the text, and it's just a Word file, so it's just the text of the name. There's no clever referencing that was done inside the files. So this is what cross-refs look like, for example, in the source XML. It just looks like that. Once we've turned it into the chunked entry, we have a thing with a class that says cross-ref designer. So we make another map, a map of all the names of all the designers and then their URL slug. So then we can, when we're processing for outputting the HTML, when we hit span class crossref designer, we can look in our index of all the names and see if we have a match. And if we have a match, then we can generate a link. And that, you know, it's certainly a little bit crude, but it's surprisingly effective. So, and that leaves us with next and previous. So these things here. So how do we know what came before, and how do we know what came after? So we need to skip aliases for this, because although we need to display aliases so you can find them in the A to Z index where you would expect them to be, we don't want them to participate in the next and previous links, because that's really between the actual entries. And these are the things we need. So it is, yeah, as I said a couple of slides ago, we're processing entry XML. So this is we've processed the word XML out into separate entry files by this point. So we do want to build the links for the bottom of the page before we build the HTML. So we're going to do that in JSON again, because I mean this kind of it's nice and straightforward, because we can do map lookups and things very easily. And then we can pass this map into every transform we do to turn an entry page XML into the entry page HTML, so it can then do the lookups as it does that. And it's just a simple lookup at that point. So we need to sort the index first of all. So we've already seen we have the A to Z index list with name and sort name. So we can use that and map for each to give us a sequence of URL slug entry pairs. And there might be a mistake in this slide. The thing that says item there may be supposed to say value. And we're using the UCA collation so that we can avoid case sensitivity, but we still care about things like diacritics. And then this goes through and gives us another view of that A to Z list that's sorted by the thing we need, because obviously this is XLT3, XPath 3, maps are unordered in XPath 3. In XPath 4, we wouldn't need to do some of this step, because provided we'd inserted items into the map in the correct order and then serialized it out, when we read it back in, that order would be preserved. We can do some nice stuff using functions and partial function application here, because generating the little entry in each, yeah, so generating the next and the previous things are basically the same data structure. So we can, the only thing that's different is whether it says next or previous at the beginning. So that key. So we can just define a sibling function that gives us a single item map back, and we can then merge into that other map. So it takes whether it's the previous or next as a string, that's the rel param, and then the actual entry itself, and that's because we're coming out of this sort. That's a 2-item array with a URL slug and the entry as the second item. So we just generate our map. So the key is the rel, so whether it's previous or next, and then we generate the map with the URL slug, which is just the first thing in the entry, because that's an array. It's the first item of that, and then the name is just the name field from the entry itself, which is the second item. And then we define a variable, one for previous, one for next, that is a partial application of the sibling function that just pops in whether it's the previous or next into the call, leaving us to. So when you then call that in place, all you have to do is pass in the entry, and it will give you the thing you want, which we can do here. You can see it. Where are we? Here we go. So previous and next. It becomes very simple. Now, again, this is a nice use of XML iterate. The thing we want to do is have a complete list, and each entry has a link to the previous item in the list and the next item in the list. But we don't want to do multiple passes through the list if we can avoid it. So what we do is, effectively, we instead of outputting the current entry that we're processing into the result with each step of the iteration, we pass in we output the previous one, the one that we just processed, and then pass the one we're currently processing as the param through XML next iteration to the top. So when we start, there's nothing in the previous param because we don't have a previous entry, which means that we don't actually need to generate a previous entry in that index. So then we go over and have one. So then we generate the map entry for the current. We go ahead and generate the map entry for the current one. I've lost myself. Where are we? So yeah, here we're checking if there's nothing in previous, then we just skip over for this one. And in the XML next iteration itself, that's where we generate the stuff for the current one. So we generate if there's nothing in previous, then we just pass the context item through. Otherwise, we construct a new array which has the first item from the context item is an array. We pass the first item through, and then we merge the array of the second. We merge the entry that we already got with the previous. We generate the previous link to the previous param, which is the one that was passed in at the top there as the param to XML iterate. And then when that gets passed back in the next one, so we've finished item 1, there's no previous item. So we just gets passed as the previous entry to the next. And then we come down, and then we have the next item. We can go, okay, now we've got one. So we then add the previous item we got there as the previous item in the current one and pass it through, and then we just keep doing that, and we go all the way through until we get to the end when we wind up with the complete list. And what we can do then is, as we have previous entries to process, we just add the current one as the next reference. So we wind up with the same thing with doing a single iteration, which I've explained quite badly and do a much better job of in the paper. And then generating the HTML is trivial. We just grab previous and next out of the map we have, looking up by the URL slug, and we're done. And that's basically enough to generate the website. But because we're doing all this stuff, we can straightforwardly produce and consume JSON with the stuff that's in XPath and XLT, XQuery 3. We can try something like a little integration with local text search in JavaScript. So we want to generate a search index that looks a bit like this. We need some IDs to be able to show and hide things in the list, which I just did with generate ID in a step that I haven't talked about because I don't want to take too long. But we can generate that with another. This is generating that document index that we pass through to the JavaScript search engine, search system from the index. And again, it's actually, this is I did this two ways. Originally, I did this as transforming the map through Ruby because it was just a JSON hash. But it was actually pretty much simpler to do it through XLT, which I was delighted by. And then the JavaScript for the search thing looks a bit like this. We can just import that JSON file that we just made, feed it into mini-search, and then we get working search. So let's have a look at that quickly. Right. I'm just, there's nothing up my, running that now. That should work. And then if what have I got? Safari, where are you? There we go. Yeah, where's my mouse gone? There it is. Oh, it looks like I've broken something in the XLT, but never mind. So now we get, I really have broken something. This is the thing where you try this a minute before you walk on stage and it all works fine, and then suddenly it stops. Hmm? Oh yeah, it did fail. That would be why it didn't work. Why is it trying to run that? Okay. I think that what's happened is I need to quickly remove a line from my rake file and it will all work again. If I can find my mouse. But this is my last slide, so I'll be done. Yeah, there we go. That shouldn't be there. Thank you for spotting that, Norm. We're able to use modern JavaScript bundling tools to turn that thing into a single. There we go. So. That's basically it all works. You need quite a lot of, for all these kind of JavaScript integrations, you need, they expect you to have stuff in JSON or something like that they understand. And it's actually really easy to do all those things idiomatically with the current versions of the standards, and that will get even better with 4. I'm really looking forward to some of the things that took me a little while to do being super easy. So that is me done. Thank you very much.
Thank you. And
I don't think we have...
if you don't starving too much, we can still have a few questions.
Thank you for that very interesting talk. I have a very formal question, and that is, you use dot parentheses 1 to select items from a sequence or from an array. You used dot parentheses 1, so you are calling as a function. Why do you prefer that over lookup operator, question mark?
I have not really got my head around all the operators, the lookup operators, to the point where I'm super happy. I have been preferring to reserve the question mark lookup operator for maps, because that fits in my head, and to think of arrays as being a thing that I'm effectively doing that indexing on. Now, obviously, I could have done it with the lookup operator, but it felt, I preferred the parens for that.
Is there any other question? Maybe I have one. Last one. Are there any new things in XSLT4 which will make this easier for you?
Yes.
Except the ordered maps you mentioned.
Yeah, ordered maps will be great. A whole load of stuff with like the pipeline operator, some of the arrowbang stuff I think would also make certain things much easier. Is so much stuff in XLT and XPath for some of the stuff that isn't implemented yet in Saxon, like reliably, and is in flux in the spec, are around template matching on maps. That's going to get a whole lot more powerful to the point where you know, the kind of XPath and XLT parts of the map manipulations become indistinguishable from trivial transforms on XML, and that's going to be brilliant.
Okay, thank you very much. And now the current template is very easy. So next thing on the schedule is lunch. Here. And it will be in the usual location, so not third floor. So yesterday it was just exception. And we will continue in this room at 2:30. Enjoy. regular person. Yeah. Okay. Because I collected short description, but sometimes it just like message to me for no title. So yeah, you'll see. Yeah, I think that third one is something like implementing in XML database or something like that. Yeah, I think that mean like yeah. So we will see. So it's already full. Yeah, because it has been closed. You can have it here. I closed 1 hour ago. Yeah. Okay. Next year, yeah. So or zero, or I don't know. I have a few ideas. Yeah, that's great.
Is it good if we try the? Is it interesting if we try the or
yeah, you
after?
can try it now. Yeah, because now there will be queue for a food anyway, so you don't have to wait. Yeah, if I will not forget to start it, I will do it forget. So it's not max, so it should be. And you have just
Okay.
But we have it also on we already asked you and already.
Yeah, because it's too early for it, but the only trouble is that do you have this kind of connector on your laptop? Please not. Okay, then it's fine. Because I thought you would like to remove because.
But yeah, we already asked ourselves what's the best. Well, it would be great if it works.
Yeah.
But
so
it would be very fair if it doesn't.
Yeah.
So
we should check during the coffee break. So perhaps I will try to create some Teams meeting and send the link to Sven, and we can check it during the next coffee break.
But yeah, we also asked him if he maybe said, okay, be sure to just show it.
Yeah, but I think it's always better to do like live presentation even if it's remote than just to listen to something to you because
yes, of course.
It's like, okay, while I'm sitting here, I can listen to this like 2 hours later.
Absolutely, I'm absolutely fine, but yeah, it would be very wrong.
I just need to check if the teams are actually working here.
And we already had presentations for the remote and other.
And your presentation, so it's on.
No. In the past, in the XML Prague, there was already presentation.
It's like in general, it works unless something doesn't work. And you will be doing also your own slides after the layout?
Well, we have slides together.
Yeah, and they are on USB stick, so we can just like upload them to some computer.
But yeah, I think we said that we try to that we make the slide, we show the slides, possibly, and he's just talking and we try to synchronize the slides.
It should be possible.
Or he makes the screen showing and shows the slides.
Yeah, but it's really better to show the slides perhaps locally because I think you will get a better resolution. Like that image quality. And maybe you will start like 5 or 10 minutes later because there are those like emails.
Okay. I wanted to ask, there are so many registrations that
it's like there are 4 after the coffee break there will be 4 or 5 minute emails which should take 20 minutes, maybe 25. So we will start like maybe 5 or 10 minutes later, then it's depending on schedule. We will see how quick it is. So you can just send a message to Liam, so maybe delay, but just little.
Ještě jenom rychle do toho, tak jste to myslel s tím videem, vy to chcete nahrát separátně každého toho jednoho člověka na ten YouTube jakoby po tom živém záznamu?
No.
Nebo během něj ukázat jakoby jména každého toho člověka jednotlivě?
Během něj to nemusí být. Já jsem, že se
Takže potom vlastně to rozdělit.
No, jde o to, aby furt ten živý streaming, že
no, jasně, jo, to určitě.
A potom, jako kdyby to bylo relativně jednoduchý, tak udělat každýho zvlášť, jako bude lepší. A hodně
oni se teda nebudou prolínat, jako ty lidi mezi sebou.
Časově ne.
Jo, ok, dobře, super. Díky.
Taky díky. So I've just sent out the meeting link to the Liam, so you can just send it to him some email or message that he should.
So you send it to me? No.
The meeting invite I send it to Liam because he will be connecting. But you can, if you have some messaging or channel to him, just tell him that we should use this Teams meeting for the presentation.
And it doesn't hurt if he's joined to explain how.
Maybe I think that it would be good to check this time. So the coffee break is from 4 o'clock. So maybe he can be available at 4 o'clock. You can try it. I'm not sure if all the wiring of sound is working. And to price. Everything working like working now and 10 minutes later. So it's the folder. It's it's in video, so I need to copy all the folder.
Yes.
Right. Yeah. Okay, sorry. I think that people are not taking attention. Close it, but not disclose it. I will give you back the USB stick so it's not. So that's 4 minutes.
This time I have no quick fix.
How did you find the T-shirt?
This is from 2019.
I got to get back in the future.
Yes.
Great.
Wonderful. Some of them has it. Here in Europe, it's not like
Historically.
Yeah.
seconds for...
Sure.
Hi, everyone. So, I think everyone is back from lunch, so sounds great. So maybe it's time to tell you a few words about one specific sister conference.
Right, so we have been asked about Markup UK next year, and so because we don't really have a date yet, yes, something will happen, and we will announce it as soon as we can, but because we don't have any dates, we do not have a location either. But let's say around June, probably the UK, most likely London, and so, yeah, hope to see you there.
Thank you. Thank you. So we have a sponsor presentation starting, and then a presentation. So please keep it. You want to switch maybe screen or which?
No, that's yours. It's almost the same.
Yeah. So it's magic from moving from one screen to the other. Okay.
Good afternoon.
Good afternoon.
And welcome again to XML Prague. My name is George Bina. I'm from Syncrosoft, the company that develops Oxygen XML editor. And as Mohammed said, I have to wear two hats now, the sponsor and the presenter hat. But I don't have those hats with me, so I will wear different glasses if you allow me. So I will put the sponsor glasses first. So we are happy to be here again. I think for me, I missed only 2 conferences in all these years since XML Prague started. The first one, and then I attended the second XML Prague, I think, and then one in between I missed. But we are always happy to be here. We have an Oxygen users meetup that we are happy to share and meet our users here. And we get always, I think, the bigger number of people that come to a conference come to Prague. So I'm here not alone, but also with other 5 of my colleagues. And you can see also a bit of who we are, basically. So I have with me my colleague Mircea. Mircea was a colleague at the university. We were in the same class. And then when we started to do some things to work in software as a company, he was among the first that joined us. And Mircea is known also for working on Calabash. So Norm, he's, like his trademark in Synchro. Then also probably we have also my colleague Mihaela, who is a project manager for the web author for the web editing tool. Then Alexandra, she went to the International Olympiad of Informatics, for example, winning silver medal, I think, there. So, and she's very young, so you see also the diversity a bit. Then another project manager, Octavian, that also presented yesterday on the development. He manages the development part, so all the XSLT, XML schema, XQuery that you work with, it's under his umbrella. And Radu is surprising always. It's like if you know that 10x programmer, that's it. That's him. He's like, you say, oh, this and this and that, like so many things. And he worked on the visual editing and now on AI positron. And and me. So we are thinking. So probably many of you are really familiar with our tools. I just want to make you aware a bit that along with the XML editor, we developed a number of interesting tools that use XML. And one of them is Content Fusion. And if you are old enough to be here like a few years ago and I made the magic moment moving a document from my laptop to an iPad and then on my phone, that is what Content Fusion does, basically. You can share easily a document and have people interact with it and bring back those changes. That was the initial part of Content Fusion, but it became also a content management system that is Git-based, and we just made available a cloud version of that. So it's very easy to get started with. So just in case you are wondering or want to try something, that's a very interesting platform. And especially to work with AI, I think it's well positioned because creates like a sandbox of your content, so you can allow an agent to change that and see without worrying that something will do something outside of that sandbox. So I hope you enjoy the conference so far and the pre-conference day as well, and have fun, and I hope you will find ideas in the sessions that are presented here. So thank you. And now allow me to put my other glasses. Oh.
Can you take your badge off? Because it will maybe help a little bit. Maybe it will be better.
Is it better? Is it better? Cool. So good afternoon again. Welcome to XML Prague. I want to share with you some ideas about AI and XML. And I think we are in a position where XML and the AI technologies can work really nice together. I've seen, it's like, all this kind of gave more importance to the structured content, to have good information, semantics, as much as we can have with XML. And I think always for XML it was an idea of having providing semantic information with the tagging on text, right? And I remember that I think I presented also in Prague creating an intelligent style guide. And I used a lot of schematron, a lot of rules for that, right? But it was intelligent to some extent. It it couldn't do anything, everything that I wanted to, right? But now I think if you combine that with AI, you can get an intelligent style guide that will actually can really check your content and give you not only detecting problems, but also suggestions of how to fix problems. So started with this, I was looking into how can we put them together, what integration points we have. So here are just some bit of information about me. I'm the founder of Synchrosoft, one of the founders of Synchrosoft, the company that develops Oxygen XML editor. And I've been working with XML for a while, and what I like to do is to find ideas, to share ideas, and sometimes, in some cases, they really get into reality. And if you went, I think 3-4 years ago at XML Prague, you know that I also dance tango sometimes. So how can we put together the XML tools that work with structure? They are precise, deterministic, but we can have some rules like schematron and so on, with the AI that allows to detect meaning or interpretation. They can reason about the content. And of course, they are probabilistic. And first thing was that where I found, but not an integration, but a use for XML in the context of AI, was that basically all the prompts that we are using for agents, for skills, and so on, they are content. And for content, if you have similar prompts and so on, we know that we need reuse. So probably many of you know that we have the AI Positron product that provides AI, and this comes with a lot of built-in actions and skills and so on. And at some point, they were developed in Markdown, and there were similar actions, and I noticed that they really depart from each other, and everything goes crazy. And then we use Data XML for managing all those prompts in Positron. So that's one use for structured content for XML connected to AI. But further, I want to look into an integration between these technologies. So one way is for the AI agents to call tools, right? So they interact with outside world via different tools. And they already do this, I think, invoking XSLT or validations and so on via tools. So AI can call into our XML tools. So the question was, what about the other way around? Can we have the XML tools call into the AI processing? So the difference is who has the top-level control, right? Who orchestrates the processing flow? And looking into this, the conclusion was that probably XPath will be the best way to provide this access. Because if we have an XPath function, then that calling into the AI processing, then that will provide that to all our technologies, because all of them are based more or less on XPath. So all of them evaluate XPath expressions. So by doing this in a single point, we allow to go into running or calling an AI engine from everywhere. So my talk is exactly about this, about having an AI function that we as a community can agree on, maybe as part of an EXPath initiative. So everyone can implement that, and then style sheets or XPrague pipelines or everything that we create that uses that function is portable between different tools. We already experimented with creating a couple of functions that I was not very happy about them, and Octavian knows that I asked him, oh, I want to change this and that, but they were still useful, they are still useful to give an idea, to experiment with this idea and see how that really works in practice. So we created an AI transform content where you just have like a prompt and content, or system prompt, user prompt, and then you get a response. Octavian created the AI verified content thinking about schematron checks, I think. So you can get a true-false check response from that. And we added also a helper function, invoke action, that to reuse our positron-defined actions. Yes?
What's the second argument?
It's like dot in the transform content is like the current element content, the current element.
I understand what dot is, but is the prompt the concatenation of the first argument and the second one?
In this case, the first prompt is like the system prompt, and the second one is like the user. We send that as the user message to the AI. So the AI has like a system user entries.
But it's all one prompt.
There will be two, system prompt and user prompt. Because, well, the AI engine will treat the system prompt differently. It has more privilege, more powerful. And my proposal is this last function, which I will call it chat because it's based on the chat interface of AI engines. And we'll go a bit into details about that. So first I want to show you a couple of examples where I use these transform content, verify content invoke actions in XSLT schematron quifixes, XPrague, to get an idea of how they are, how they can be used. Discussed a bit the limitations they have, and then show you the AI chat proposal. So the actual signature for transform content, it has the system prompt, the content, and then it can also continue a conversation with assistant user, and then you get the next response. I will go quickly over these because they do not provide too much information. And we can just go, I think, more into the samples. So here, for instance, we can match on a topic title, for instance, that does not have a short description, and then copy the title and generate a short description immediately after the title. So this will call the transform content and will send a prompt to generate the short description and pass the document content. And that's it. So this can be used, for instance, in a style sheet that will process maybe 1,000 topics and will find exactly the topics that are missing the short description and will add that to those topics. So you can see in this case, we take the top-level control. And we decide when we call the AI specifically on just a part of where we actually need that processing. A similar fragment in XQuery. Here I added let's say a schematron check and a quick fix that will use AI. So in this case, I use that verify content function, let's say, to ask, is this too vague, too generic, off topic for this content? And then I provide the existing short description and the actual content of the topic. So the AI can check that meaning. And as a quick fix, we have this rephrase that will basically use transform content to ask the AI to generate to rephrase that short description. We pass that information, maybe it's useful, the previous short description, so that the AI can have all the information and generate a new short description. And this will replace the existing one if the user will invoke this quick fix.
Forgive me, George. I just really want to understand what's going on here. Why have two calls if you're passing just a different, what you call the system prompt? When I think of AI, I think about single prompt. It's atomic. It's a single sentence. And it has two pieces here. And then you've got two different calls.
Yes. Yes. So again, the AI, when you interact with the AI, usually there are two prompts, not one. You can just put one optional, send it empty if you want. But when you interact with the AI, there are the system prompt and the user prompt. But
I'll accept that. What's the semantic difference between verify and transform?
the first is the schematron part that detects that the short description is off topic, for instance.
No, I can read the code. My question is, what is...
Could you maybe save this for the Q&A session?
Okay.
Thank you.
Another use case that I've been using this was to enable AI support in XProc by defining some XProc custom steps that can invoke AI processing. So I created an invoke AI step, and here it is an example where it's a part of a pipeline that takes release notes, for instance, and generates a press release out of the release notes. And these are like two processing steps. One that will generate a draft press release, and another one that will take that and adapt that press release to the style, company-specific style of press releases, for instance. But as I said, you can use this everywhere where the XPath is available. In Oxygen, we have XPath available in many places. For instance, in new document templates, you can write, we call them editor variables or editor functions that you can put in a template, and they are expanded. And one of these editor functions is an XPath function. So then, for instance, when you create a new document, like a new concept, you can expand that concept with AI to have a first draft information about that concept, for instance. Another place where we can use this in custom actions in the author mode that can be placed in the document. So for instance, you can have in the document some buttons, and when you click on them, the document content is populated with some additional generated content. Another interesting idea was that now that we have the AI available in our technologies, then we can use XPrague, for instance, as a test framework for AI prompts. There is no testing framework for AI, but once the AI is available in XML, we can use that. We can use XPrague as a unit testing for AI. So here it is an example of a scenario that will call. So XPrague can do a lot of things, but in this case, we test the result of a function. And the function is exactly the transform content function. So we can invoke the function, and the result will be in the result variable. And then we can just parse that and make sure that maybe the root element is short description. So we can assert that the root element is short description. So what we generated is actually a short description. And then we can also have a check with AI further to make sure that the short description matches the actual content we try to describe. So the interesting part is that you can combine like classical checks on the result with AI checks, right? So this gives you also an idea that you can use these AI checks also for other cases, for other, not only to call an AI function, but you can call whatever, but the checks can be made also with AI. And doing this, I realized that also schematron can be used as a test framework. Because I can describe in an XML document what I want to test. So the same example here, I just created a custom XML structure, like a suite of tests, and then for each test I have the prompt, what content it applies on, and then I can say expected root element and expected similar result. And then the schematron will match on such a test, and will use the prompt and the source to run the transfer content. So it will run that prompt on that content and put that in the result. And then I can, for the root element, I can just say that if the result matches less than, starts with less than and the expected root element, and then I say wrong root element, or for the similar description, I can say the result should be similar with this from the XML test suite. So that allows to easily generate and test the same type of action with different data. And I compared a bit these two approaches here. Determined that I think what I miss from XPrague is diagnostic information. So XPrague unfortunately does not have support. When something fails, you cannot really have additional information. So these are a few of the examples. I have a lot more, but just to give you an idea how this may work in various technologies. And what I want to do further is to propose this AI chat function, because these older functions that we have, they have very limited history information. You cannot easily continue a chat and so on. No tools support, tool calling support, and so on. And again, they are tied to Saxon because we implemented them as a Saxon extension, then Oxygen Positron. So having a specification for an AI chat extension function that will be adopted by the community will be a good thing, because then a style sheet or an XQuery or an XProc will work with any tool. So basically for the AI chat, there are two parameters: a list of messages, a set of messages that are sent to the AI, and some options, like what engine name you are using, and so on. So to control a bit the interaction with the AI. And the result will be a map with the response from the AI, the entire history of messages, and maybe error information in some cases, and warnings. Here I have some example interaction, how this will work, for instance. So you can say, AI chat, what is a short disk? And then get the response. Or to continue a conversation, you just get the messages, the previous messages, and add another one. And then you get the response from the second interaction. Here you have an example where we provide, so if we do not specify anything and we just provide a string, that will be like a user entry to the AI as a user prompt, not a system prompt. In this case, we can specify specifically that the first entry is a system prompt and the content of that. And then as a user, we can ask something. And here is like a utility to serialize the entire content of the response as a JSON. So the messages parameter has basically, you can specify directly a string, and that will be considered like a map with the role user and the content that you specify in that string. You can specify specifically the role, and if you specify the previous messages that you received from the response together with additional entries, the messages will be, this is an array, and then that will be understood to be, like will be expanded into all the messages in that array. For the options, we have model, temperature, mass tokens. These are specific AI parameters that are in the API that we call further into the AI. In addition to those, we have this cache, which is true by default, that allows, that is useful. I found that very useful, especially when testing, because you don't want, if you have exactly the same input that you send to the AI, you don't want to pay for that all the time. You can just get the same answer. on error, this allows to control whether if there is an error, you get an exception or you get the error actually into the errors result in the map. And the tools allows to pass tool information to the AI engine. So then when you invoke through the AI chat, you can call, the AI can call also various tools, and then you get an agentic reply, not only one AI invoking the AI to provide you just an answer. So for the tool definitions, for the tool entry, it will be a JSON string that looks something like this. This is the standard way, I think, for OpenAI to provide tools. So it's like an OpenAI-like API to provide tool information. And this, I think it's our get document content tool, for instance, is described in this way. So the AI chat will receive a map with the response that will give access to the last response from the AI. The messages, an array of maps. Each map will be an entry. So it's the entire history. And here you get also the tool call information. So when you invoke the AI chat, you will receive one response, but you can receive many messages if tools are called, and you see the tools, the results, and all the history. So then you can continue the chat passing the previous messages and adding additional messages that you interact with, that you want to send further. The error and warnings, the error will be populated only when the on error option is set to return. Otherwise, if there is an error, you will get an exception that you can use with try catch also in XSLT or. And to try to keep, this is an additional function that I want to add because we had previously the invoke action, and we want to reuse those positron action definitions. So invoke action will be the equivalent to calling resolve action on that action and then calling the chat with the result. Yeah, so more or less that's it. I put this also in the form of EXPAT candidate modules. So it's written also in that form. And yeah, so I will try to put this on GitHub maybe. So if you are interested, you can look into that or contribute, send feedback. And one of the idea that is to find also where we should go, because EXPAT is, I think, no much activity was done in the last years. So I'm wondering also where this should go, or where this should stay. So as takeaways, the XPath integration layer allows to access AI from all the XML-related technologies. The previous functions that we had allowed us to experiment with how that will work. And this AI chat kind of covers the full conversation history to continue a chat, to control all the options, including model tools. The question where this should go, maybe some of you have some ideas. And I also listed some open issues that I'm thinking about, because now the tool calls happen on the service side. An idea would have been to kind of set an option, so when there is a tool call, we'll receive that at the XPath as the result. And then, let's say if we call this from XSLT, then we have to implement the tool response in XSLT and continue the chat if we want to. Streaming mode, AI provides also the streaming mode. I'm not sure how that will work in an expat context. And I didn't cover yet the structured output format. So these are like still open things for this proposal. Yeah, so thank you, and I hope you got some ideas with this. And if you have any questions, I'll be happy to answer them.
Thank you. I fear we don't have much time for a question, because, but I think if you have some question, especially if they are detailed question, maybe we can keep them for the break later. Unless there is a very short question with a short answer. No.
Adam.
Who? There, you sure? Sure.
Thank you. What about the costs for using the additional AI functionality?
Short question.
So my proposal is for a common expat function. So the costs will be related to that AI engine that you are using. So if you put maybe a local engine, there will be no cost. If you connect to whatever.
Okay. So thank you very much again for the two presentations. And our next speaker, Jorge.
Okay, it sounds good. Yeah. So, okay. Does it look good? Okay, good afternoon. My name is Jorge Sanchez, as many of you know. I have been working for more than 20 years in software consulting companies in roles like development, analysis, and management. About 2 years ago, I was working in a component for XML and Java binding. And then I got the idea that the solutions that we had didn't match what I expect from the XML side. In Java, it made a lot of sense, but the XML side seems short in capabilities for what we do. So I thought about bringing this small presentation and a small proposal for adjustment. And I also bring a prototype for testing the idea and the solution. I will try to explain the key concepts that are not very big. There are small adjustments. We are keeping most of the Java side for the Java part. We are using Java notation, which is very common. We will try to, it's important for us to work with this path, modern path. For people from other contexts, Java still relies in many cases to XPath 1. We also have XSLT 1 in browsers. It's time to get updated to the XPath 3.1 or the current version. On the document side, most of the Java XML Java binding relies on the idea of object serialization, so they drop and rebuild the documents all the time, which is not ideal and doesn't match what we usually need, because document can be extremely complex, have a lot of intricate elements. So the idea is to preserve the document, load specific information, go only to the specific nodes that we need, take it to the Java beans, do whatever you need in your logic, and then serialize only that part of information instead of tearing everything down and up again. We don't expect that both data structures are aligned. There are cases where it makes sense. If you are like sending and receiving from another service information, it might make a lot of sense. But if you are working with specific aspects of documents, you probably will focus on one aspect and not the whole document, and you don't have to have everything aligned. We use the repository abstraction for simplified file access, and so let's get into it. Let's take a look at the solution, how it looks. For annotating Apollo, we will we will need to implement the serializable interface. We also require to have no arguments constructor for each plain Java object. Once you have these, you can start marking your annotations for classes and fields. Okay. As you can see inside those annotations, the most important parameter is the XPath expression, regular XPath expression from version 3, and I think that we are using 3.1. And that has its consequences. We'll talk about it a little bit later. This is another example of another bean, similar but with namespaces. The namespace syntax, I think that it could be improved and simplified a little bit in the next days, but you can use both wildcard and namespaces. So what do we need to make it work? We use the repository abstraction. We will configure it passing the path where we locate our files. We create one instance of the Pollo that we are using to map to the XML file. We will typically load it from the repository using this object as a parameter, and we will receive it, the parameter filled with information. So, for example, in this case, let's run it as a JUnit test. And as you can see, we have the information loaded. That's basically this is basically what it takes with the approach to load information from XML, and very little more to put it back again. If you want to see the file, this is how the XML file looks like. Sorry if I went too fast. So why do we need XPath? This is one of the first questions. Is different. How do we? Sorry. It's different how we explore a document and how a Java developer might do it. If we take a very, very simplified structure that could resemble a book structure, not sorry, because it could be, it is extremely simplified. If we have like a book structure with chapters and contents some master information like title and author, and some entries in the glossary. And we say to a developer in Java that we need to get the contents from the first chapter and then prepare the page with the title and the author, and then get the entries from the glossary for this paragraph. Typically, a Java developer will build all the structures, create a similar structure in Java, run over take the variables for the master information for the paging presentation, run over the chapters until he gets the one that he needs, and then another loop to probably keeping track of glossary entries that could find in the middle, then go again over the glossary from the object structure. They need to be very verbose and go over all the elements and describe the small steps of the process, which is not ideal if you have a very big document that might have small adjustments from other teams that we might be interested only in a part. Also because we are used to work with relations between elements. For example, if you are trying to get the glossary entries from the first chapter, you can put it just in a XPath line and say to the interpreter that you need those entries from the first chapter. You can also put in one line to get the contents of the first chapter, and you can work back and up along the structure to get the master information. There's something difficult to explain here is that why do Java developers and the people that build these kind of tools don't care about these relations, about elements, and the fact is that in an object structure, they might not make sense. I mean, if you have a string variable, it doesn't make sense to ask the variable which is his parents, his ancestors, his siblings, but an element in a document has a position, and the relation with the context and the related elements make sense for us. So this is important for us. Let's take a look at how this mapping could look like. This is a working draft example that will be uploaded in the next days. So not all that we get from Java is bad. Java makes it's useful for interacting with other systems, and the simplicity of the JSON data model related to the Java object obviously is an object notation and is aligned. It makes it easy to control the inputs from the outside, and it could be a good tool for in combination with XML. So we can have a security perimeter that has a limited size, and on the inside we can work with the details and the flexibility from the XML side. So let's get, sorry, I missed one of the samples. Okay, if we, for example, we have one repository type that can take the information from the class path location. So as you have seen, in Java applications, the class path is an important information that we can use to locate, for example, configuration files like the log4j file and update the information. And getting into collections, sorry. Okay. XPath is very good at locating information, even in flexible and when we don't know all the steps that we need to get to the final path. But we have some limitations, and that's that lack of information that we might not need to provide to specify where the objects are, where the elements are a problem when we need to create new elements that we might not have all the information to say. If we provide an XPath expression where we have like queries based on attribute values or double slash notations, we might not know where we have to create a new element because there might be more than one node candidate. When we get to collections, we have another problem, is that we might be updating only a small fraction of an element, and some of these elements might be new, some we might just switch in position of the elements, and with the collections we have more complexity. At some point we might need to switch to a more complex solution if we need more demanding requirements. We have several types of strategies for mapping collections. The default is by key. We have to provide in one of the fields of the class, we have to provide a parameter that is used as a key. The second option is by position. For example, if we are navigating a spreadsheet table, a spreadsheet table might have a name. A spreadsheet table might have a name, but if, sorry, it's in the sheet, not in the table. Okay, so we have to mark one of the fields as key, but then we have situations like, for example, in a spreadsheet, if we get into rows and cells, there is no option to work with orders. We just go, the first row is the first row, the second row is the second row, the third row is the third row, and so on. So we can use a position strategy, and also we might use a full reset, which means drop all the sub-elements and create them again. Also, sorry, okay. There's also some difficulty in finding out which elements we might remove. So we have another annotations to specify which elements, if they are not there in the object side and we persist the information, if we should remove the elements from the XML document or not. Okay. So, for example, if we work with a spreadsheet, let's open. Sorry. Let's go to something. Okay, we have an ODS spreadsheet. We have some values there, and we have a file, so we can map the cells and update them. We are going to run the example. which implies recovering the content file from the inside the document and update the spreadsheet values from the ones that we have here, Juan Pérez to Jacinto Gutiérrez, sorry for the names. Let's clean it just in case. And running, okay. So it says that it worked. So we are going to go for the test. Target test classes. And you have the updated values as, sorry. So, okay. So, the repository types are another of the, okay, yeah. Another of the abstractions that we are using. We have several repository types. We mostly use this file. We have another repository type to work with REST services. We have a class path repository to access files on the class path. We have zip repository to access ODT and ODS and several Office-like files. And most of the repositories support the adjustments of the path based on the object properties. So let's take a look at one of the last examples. If working with a spreadsheet is kind of easy, working with test documents is even easier because we can just map it using the text value of the nodes. That means that we could add another, open a simple document, add another value in the text, don't even configure the open document text, and match it based on the test content of the paragraph. Okay, so we are going to run this. Let me close it. So. This is a zip repository type. Apparently it worked. We are going to open it and we are going to see the values updated. This is what it takes to load the document content on the object, and this is what it takes to persist the document contents. So in general, I think that it doesn't make sense to bind all the complexity of the documents into Java like we do. The approach has its limitation, is not for the most complex cases. The prototype is still it needs some love. The placement of some of the elements is challenging. We are rejecting anyone that has some imprecision at this point, but it could be adjusted a little bit more. And we know that we have not the best time to talk about XML and Java binding. In general, I think it's a very easy approach for Java, for some people that working with objects is a very easy way to start and to access an XML document, very simple. It's natural for them and enables to do part of the work that we do with XML from Java, and maybe even for some more people to understand what we need. Front on next steps. I probably need to rename the component because sorry for the our good sponsor from other years. There's an unfortunate similarity with the name. Also, there are a lot of work that should be added. Collections could be, the definition of the collections could be improved. There's room for work there. And in the next months, we'll see if we can get some traction. So we have 5 minutes for questions.
Any question? Where? Where did you? Oh, that's you again. I have a blind spot.
Thank you for the presentation. It's very interesting because Java will get way more traction when it comes to AI in the future, so that fits very well. My main concern is performance because XPath expressions tend to be slow on large documents. Have you made speed evaluations whether this really gives a benefit from a speed perspective or only in quotes from a memory perspective? Thank you.
It's not the most performance focused solution. We are I'm using Doom to implement it. So, but we are in prototype stage, so it could be improved in the future. Okay. It should be more than enough for configuration files, but maybe not for the most demanding cases.
Oh, you ready?
Sorry, because mine is a follow-up question, because I was asking myself how you implement the repository, so the loading and then the again. And you said you are using DOM.
Document Object Model?
Yeah.
Yeah.
Unfortunately, I was like, oh, hopefully this is more performant than using the whole DOM.
No, we are not yet into making it go very aligned, very fast. But it should be more than enough for configuration files and for generating some report from time to time. More than enough.
And one last question. Oh, okay. So no question. Any other question? No? Okay, thank you very much.
Also this man. Hello.
It's hard to operate, so put the microphone on because this.
Test. Okay, test.
To connect the laptop.
Yeah.
Of course. Okay. Hello, XML Prague. So unfortunately, I didn't get the memo.
saying it wasn't a demo jam that was in a brewery where we were going to get drunk and do silly things. And we are a fully remote company, so we don't get to see each other very often. And coming to conferences is a good opportunity for this. But I'm also a bit of a tough boss at times. So when we come to conferences, I try to make my employees do presentations, which sometimes they enjoy and sometimes they don't. So late in the lab one night, I was thinking about Eunice and him coming to Prague and what we might possibly create together to present. And we have a bit of a no AI policy at work, but Eunice has a background in computer vision and AI. And I thought to myself, what would happen if I told Eunice to just AI the hell out of it? And then I thought, what could we do with that? And I thought, I wonder if Elemental could run Doom. Because I grew up playing Doom and Wolfenstein before it and various other games. And there is this whole meme about Doom. Yeah. And over to you, really, Eunice, to see how it went.
Yeah, so first of all, it was 2 weeks before the conference.
Oh, yes, sorry. You only had 2 weeks as well. Yeah.
That's a really big point. So Elemental, can it run Doom? Well, first of all, the first thing that I thought was like, okay, can I get Elemental to run on xQuery? 2 weeks, me and Claude, definitely no. It's going to tell me that it's possible. It will do it for me. It will not work. So that out of the box. The second option was, let's find a Java port of Doom that works. That took a day just to get one of them to work. The second option, let's integrate that into Elemental. And Elemental offers you the option to add module into it. You can bake modules into Elemental. And that's what I've done. I went ahead, I found a fork of Doom called Mocha Doom. It works, it renders to AWT. And I vibe coded the crap out of it to remove everything that's related to rendering, getting the audio out, taking inputs. And then after that, I said, okay, it's a Doom, it's a library. The game loop is still there. The whole engine is still there, but it doesn't do anything else. So let's see how do we get that out. So the first option was like, stupid, simple, let's do frames to file. Almost blew up the computer, had to restart it.
So how many frames per second were you rendering to your hard disk?
10 frames. At least, I think 5 or 10. I set the limit, but I'm not sure if the limit
How
worked.
many gigabytes of images did you create?
25 within 10 seconds. I just pressed the button directly, just off. I wasn't fast enough to pull the plug. So that was the initial attempt. The second attempt was like, okay, let's go STD.io. So STD.io was what's simpler. So that kind of worked, managed to render like 1 frame per second or something like that. It was quite slow. But the final thing is like, hey, WebSocket. And then it worked. I'd start adding it to Doom, so I started creating some xQuery functions around that. And you can see there is a Doom module in here. And you can actually import the Doom module, and you tell xQuery, hey, start this Doom module for me, start it here. And then we can just go ahead and tell it, hey, run the Doom script. So in the Doom script by itself, you can see it's the instructions to get it to run, and some HTML and some JavaScript just to render, but no game logic, no game loop, no nothing. And here's Doom. I mean, yeah, you game, and then there's Doom. And it's playable. You can actually shoot stuff in here. If my computer lets me anyway. So that's Doom. And that's it for you.
Can Doom run in Elemental, Eunice?
Yes. But not as xQuery. Okay, and that's it for you. So Doom is running on Elemental.
Thank you, Eunice.
Okay, hello everybody. My name is Ondřej Kyba and I'm a computer science student here at Prague University of Economics and Business. And today... Oh, I'm sorry. And today I will show you a project that I've been working on as a part of my bachelor's thesis. Hopefully it will load.
Potřeba něco tady v tom počítači přepnout ty Windows nebo něčem. We tested. Oh, it was okay.
Okay. So yes, this is the project that I've been doing as a part of my bachelor's thesis. And basically it is an isomorphic app that shares code base between a server and client. And as we can see, the main idea behind this app was to combine the advantages of server-side rendering and client-side single-page applications. And to prove my application works, I have actually used Saxon 12 documentation as my data source. So let me show you how it works. This is the application, and you can see that I have the network tab open. And if I refresh the site, hopefully. Oh yes. If I refresh the site, you can see that the first initial response was from the server, and it was rendered entirely on the node server and then sent as HTML document to the client. And after that, the single page application takes over, and you can see that it works normally as the Saxon 12 documentations. To show it better, if I disable JavaScript and reload it again, you can see that this is the response from the server. And if I go through the documentations, the server renders all the pages and then sends it to the client. And so the main problem I had to overcome was that the original Saxon 12 documentation uses interactive extension, which doesn't work on the server because it uses browser's window object. So I had to make a server transformation template that neutralizes these functions so that it could transform and compile on the server. And yes, I think this is what I wanted to show you. And feel free to check out my GitHub. All the source codes are available there. And thank you for your time.
cool. Yeah, I can actually hear myself. So, hello, my name is Martin. I am doing 3 things to bring bread to the table. I do a bit of consultancy for Exist Solutions, and I think we have talked about that a lot lately. I am also doing some consultancy for Fonto XML, which is an XML editor in the browser. That XML editor has 2 big API services. One API service is in TypeScript, and one API service is in XQuery. And I'm doing a bit of consultancy now at a different company that is mainly a JavaScript /web/Go company. So whenever I start talking about XQuery, they just like, meh, I don't want to use it because XQuery is not really supported anywhere. And I just don't want to do that. So what I built is an XQuery step-through debugger that does a couple of things. I'm going to put myself over here so I can actually see this. I have a piece of XQuery script over here. I can instrument it. I can go and open the DevTools. I can open the DevTools. I can open the DevTools. And in these DevTools, I now see a stubs folder where I have this, where I have my XQuery script, where I can place some nice debugging breakpoints. Now I can run this thing, and I actually get my debugger to break over here. So in this XQuery, I do something with a loop. I first output small, then I output thitch. I can do a bit of mouse overing here, and I see that I'm now at 2. I can click here, and I can click here, and I can continue. I now have mouse overing over label, and I see that I'm returning this label. If I now close this, I see that my whole output is over here, is this. So how I did this is really cool. This is all vibe coded AI slop. That's why it's not fully open source yet. I will first go over the code to make sure that Cloud didn't make any whatever backdoors. So how this actually works is I have this XQuery. This XQuery I parse using XQ parser, which gives me an AST. In that AST, I use a visitor pattern to go over my different nodes, my interesting nodes, and add a special callback function in it. So I kind of like make this. So blah, 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 debug trace, debug trace, debug trace, debug trace. All of these functions are being implemented as JavaScript functions, JavaScript callbacks here, which I then source map to the origin XQuery. So therefore, Chrome understands like, hey, there has a bit of a script over here. I can put a breakpoint, and the breakpoint is actually kind of like this line over here, and stuff just works. This cost me like a few thousand tokens, and it just works. Right now, the engine underlaying this is Fonto XPath, which is the other export engine. I am quite sure that Section.js I can make it work. And I am also quite sure in the other engines like Exist, Basics, whatnot, MagLogic, I can make it work as long as I can hand over the process control from the backend to JavaScript for a bit and then back into the backend. And that should just all work. The second thing I want to show is a really cool use case, in my opinion, of XML. So I am getting married in a bit. Remember I said at the start I bring bread to the table in 3 ways. The third way is I make beer. I actually opened my own brewery last time, a few months ago. So I am now making beer, and I'm getting married, and one of the things I really wanted to do, because I'm Dutch and I'm cheap, is I wanted to make my own beer. So there's a brilliant software for beer. This is not mine. I need to say that this is just an open source implementation of beer recipe editing. And you have these kind of really cool thingies where you have different like scalars, and depending on the mesh that I use, depending on the fermentables that I use, the color changes of beers, yada, 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 yada. I also have a really cool beer making machine, a Spider Braumeister 50-liter one. It's not cheap, but that one actually is programmable, so I can have my meshing steps in different temperatures. So the usual way how you would then do that is just copy over, copy over, copy over. No one likes that. So did you know I can export stuff? Please ignore the beer JSON. Beer JSON comes first, but beer XML is actually the de facto standard for beer recipes. And a beer recipe expresses the different mesh things, which then I can upload in here into my Spider Braumeister, where I get my full meshing step. So the computer just says, I'm going to do that, I'm going to do that. So I have a few seconds left. I'm going to show one last thing, which is here. This is the beer that's now fermenting at home. I made it last weekend, made by XML. Applause. Woo. If anyone has any questions, fight me later.
Thank you. If you came on Thursday, this is a short summary of the bits that you might not have noticed us doing in more detail in the Saxonica demonstration. I want to show a couple of features of XPath 4.0 running in Saxon 13, which we shipped last week. I'm using Saxon's Gizmo tool, which is a built-in part of Gizmo that enables you to evaluate XPath expressions interactively. And the features I want to show you are related to JSON processing in XPath 4.0 as implemented in Saxon. I've loaded a document called books.xml, which I'm now going to show you, and I'm going to sit down because I can't type standing up. So this is the document. It's a collection of books by the German author Hermann Hesse. They're all, some in English, some in German, but they're all basically either Das Glasperlenspiel or Steppenwolf. And the first thing I'm going to do is to convert that from XML into JSON. There are lots of functions for converting XML to JSON. There are lots of tools on the web for doing it, and they're all extremely bad. The reason they're bad is because it's actually a difficult task to do well. We wanted a tool in XPath 4 to enable you to do that conversion, and we wanted to avoid the mistakes of all those tools on the web. Let's show you the default way of doing that conversion, which might illustrate why that it's a difficult task. So the function is called element to map. I've left out the show command, which will display the result of the function on the screen. I've got to give it an element rather than the document, so I do a /*. And that now displays that file in JSON. Now something's gone wrong there. It's displaying some of the books nicely. It's displaying others in a very ugly way. The reason it's got it wrong is that this book has two translators. It's using an algorithm that says if all the child elements of an element are distinct, then I'm going to convert to a map. If they aren't distinct, then I've got to find some other way of doing it. Now, some of these books have distinct child elements, some have different child elements, and so they use different algorithms for the conversion, which makes the result totally unusable. How do we solve that? We allow you to parameterize the conversion with a plan. There are two ways of creating a plan. You can create a plan either by analyzing a corpus of documents, or you can create a plan by hand. I've created a plan by hand, which looks like this. It just says for books, use record layout as if the elements were all distinct. If I now use that as the second argument to my function, I've got something wrong. We now find a much cleaner translation of the element to JSON because I've told it what kind of mapping I want to use. I've now got JSON that I'm going to bind to a variable so that I can actually use it. Why don't I just call it J? And I can now, the other new feature I want to demonstrate is doing path expressions on JSON. So I can now do very familiar path expressions that we're all used to, like that. The result of the path expression is a set of J nodes which behave very much like the nodes that we're familiar with. And I can use all the traditional axes and the predicates on those. So if I want titles that contain it would help if I could type, wouldn't it? Then it selects some of the titles. And I can select up, I can do things like this on it, so I can navigate upwards and sideways and downwards, and any way that I can do in familiar XPath can now be used on trees of, the kind of trees of maps and arrays that you get when you parse JSON. So that's all I wanted to show. Thank you.
Thank you very much. So now is the coffee break. And then there will be other Ignite talk in like 27 minutes.
no, I misunderstood. Who is it that you were here? Who are you speaking with? You said Raju?
Můžu poprosit režii, aby zapla zvuk z počítače, tady toho, aby šla do beden. Ne, tady z toho zabudovaného, z toho audio jacku. Je to tady, no.
So I wrote a functional API, an API of functions, that is, to access things.
Jo, a můžete to přidat, protože to není slyšet v té místnosti vůbec.
Every node in both documents, the original and the changed, should be marked one way by the matcher. It can be marked as identical, it can be marked as corresponding, it's a match. It can be, but maybe it's got different attributes or something. It can be marked as an insertion or a deletion.
Tady to je naplno všude, no.
The text content is different, or a move, or maybe the element name is different. Later we made special case wrap and unwrap and split join too.
Buongiorno. Hello.
Again, performance is secondary to correctness.
No, takhle je to dobrý asi.
But secondary to correctness, it should only mark things that are different
Dobrý,
in the
díky.
two documents. So I think we've achieved that.
Sounds like a railway station. Who is Mick? Can you hear me now? If I try to speak? No, it's got the right microphone. Video settings are correct. Let's make a volume control. Okay.
Ale je slyšet docela fajn, já nevím, no někdy bývá člověk daleko od mikrofonu, nebo jestli má dva mikrofony, bývá na tom, že jo, a pak mají lidi, se nemají čím zakrytý.
Well, I can see. I can see volume. I have volume. No success yet. Ah, perfect.
Já nemyslím, že má problém.
Já taky nemyslím, teď ho slyším.
Can you hear us?
On nás neuslyší.
Já si myslím, že ne, že tady ten mikrofon jako
to by měl být tenhle mikrofon, ten to má brát. I kamerka, jo.
Aha, že kamerka by měla fungovat.
No. Hello. I can see you, and I can see me in you. And I'm wearing the same T-shirt.
But you cannot hear us, correct? You cannot hear us.
I can hear you.
You can hear us?
I can hear you.
Ah, that's cool.
Then everything works.
Ještě vám můžu dát placatý mikrofon do USBčka.
So we are
tady drálí, když tady budou, ale aby to nedělalo nějaký...
Já bych to.
Radši to nebudeme předimenzovávat. No.
Okay, so Liam, will you be sharing some slides during your talk?
Someone will be sharing slides. I don't know if you want me to or Nico will. All right. Yeah, we have it on the. We have all our slides on this laptop. Oh, okay. So Nico can share the slides, and I'll just ask for the next slide when I need the next slide. How about that?
Yeah, but then people will not see you because he will be sharing the slides. It will be like this, and
That's fine. Unless you can make a little me.
slides can fit in the middle of the screen. We can do it like this. I'm not sure if the layout of the slides will be working.
Would it be easier if Liam shares the slide?
Yeah, because it will be like full screen and just Liam's head in a corner. Because this is the way I like meeting.
And Liam, you have the slides. So
Yeah, but I think if you look at the screen, maybe it's okay.
Wow.
I'm not shooting it from large image, but I think it's still readable. So we can do it this way. Okay. So Liam, I will mute. Maybe please mute yourself, and we will mute ourselves, and it will be like in. I have to check the schedule because I forgot the time. So
20 minutes.
so it will be like in 30 or 40 minutes. Your talk. Yeah, because now that there is still coffee break, and then there will be like 4 in-night talks and short demos, and then it will be on you and your friends. Okay?
Yeah. Yes, coffee sounds good. I'll have some of those almond cakes.
Yeah, so you can make yourself coffee or tea as well. Okay, so speak to you soon. And
I have a question. When I present, I should like only I put the HDMI and it works.
yeah,
And it's.
but we can test it right now.
Let me bring my laptop.
If you bring your laptop. Yeah. I can unmute him, mute him very quickly just by pulling this plug out. Okay, so it will be okay. You're welcome. And isn't this yours? This maybe it's from presenter. But I will give you back the USB stick. USB stick.
Yes, thank you.
So is it? Yes, it works. You are working with this one in Italy?
Yeah,
so you are studying at university?
Yes, at Ghana. Doing my master's there.
That's cool.
You know Shukla?
Yeah, sure. He even attended some.
He's very active, yeah.
Yeah, I think that around the time the JSON has been born, there have been a couple of XQA working group meetings, and there was discussion if this should be really part of XQA, but it was delayed, so I think that just one created like separate language.
Yeah, exactly. So, yeah, here it's gonna be like very quick. I'm not gonna talk any technical stuff. Just show a quick demo.
That's cool. And I like this story because my very good friends from the high school are really they need some technology to the series.
Like working there.
Yeah, and my friend is working at Google, like, and they are here for like 10 or 15 years or whatever.
Okay.
Kids which are almost 18 years old.
spending the summer in Dublin.
Yeah. I think it's good to see some different places.
Yeah, exactly. And now I can maybe back to Zurich after.
Yeah. And you are like living in Switzerland or just?
Yeah, studying. I'm originally from Lebanon.
Yeah.
I moved to study. I did my bachelor's in Lausanne, and next to Geneva, the French part, and then now Zurich master's.
Cool.
That's great. Yeah. Nice presentation.
Yeah.
Yeah, I think I'm the fourth one, the last one.
Yeah. Third, yeah. Cool. It's a little bit stressful. It's so quick.
Because setting up
And I need to start finally. This is very old phone, and the application is really hard to control, but it has large numbers, so it's an advantage.
You're one of the organizers?
Yeah.
What's your name?
Luca.
Ah, okay, you're the one that sent the mail.
Yeah.
Okay, nice. Are you organizing like recently, or you've been also organizing for a while?
Yeah,
last time?
I'm organizing it since second time, so for more than 20 years now.
Okay. Yeah, okay. That's nice. Yeah, for me it's my first time coming. So.
And did you enjoy it?
Yeah, it was really nice. Gisela, I think he was also supposed to come, but he couldn't. Like, he has courses and stuff.
Interesting to see because what the JSON is doing, it's now something very similar will be possible in X report.
Yeah, exactly. We're integrating it. Yeah, it's part of it's really funny because like in an XML conference I will be presenting JSON stuff.
Yeah, but it's true that a lot of people originally working with XML needs to deal with JSON because a lot of data is now coming in JSON. But the tooling for JSON is very like poor and compared to XML set. So they try to like just bringing the level of tools for validation and querying to the JSON world for JSON, and then now it's even better support for JSON in each version of its class and sort of thing. So I think we have the best tools for dealing with JSON as the XML community, but no one knows outside the XML community, so that's a good question.
Trophies and tools. Do you also go to other conferences like Amsterdam?
Yeah, I've been in Amsterdam last year, then the year before I've been in London, so I go to go there. But I'm usually not going to the Balisans because it's too expensive and too long.
Where is it?
In Canada. Now it's virtual, but before that it was been in Canada and in the US. So.
Now it's virtual and you have to also pay.
Yeah, but it's $250. But when it was been like physically, it's been like $1,000 or something.
Oh, wow.
Insane. And then you have to pay additional $1,000 for hotel,
minimum, and flights and everything.
And I'm not sure if I would like to go to the US during the Trump government. So.
No. Okay. Cool.
Grab a coffee.
Yeah, before.
Oké, dan ga ik gewoon klassiek classic vertalen.
Oké.
Ik ben er al. Nee.
Even waar ik toch even mijn memory stick doe.
Werkt deze ook bij jou?
Ja, maar ik doe gewoon Spaanse taal.
Oh, dat mag ook. Ik vind het wel leuk, dat is veel leuk om te blijven.
Ja, dat is waar. En ik had ook zo'n apparaatje, die ligt ergens in een la.
Oké.
Ik kon het niet meer vinden.
Ja. Maar deze werkt echt niet meer?
Nou, misschien wel.
Kijk eens.
Terug.
Nee.
Welke grote zijn er?
Nou, de grote is vooruit.
Oh ja.
En deze werkt heel goed. Ja, waarom zit jij dan? Oh, natuurlijk omdat dat hier in de presentatiemodus staat. Ja.
Oké.
Ja.
Dus, nou. Wauw.
Ja.
Oh, je hebt gewoon speaker nodig. Nou, wat is die?
Nee, niet dat ik weet. Ik doe niks. Ja, dat is de klok of zo die je daar hebt?
Ja, dat is de klok, ja.
Oké.
Ja. Nou, geweldig. Ik ga eens even die laptop kan ik al aanschrijven. Wat zie je nou even doen?
Ja. Dat heb je nu niet, hè?
Nee, maar volgend jaar.
Ja.
Reservation is confirmed.
Oké.
Wow.
6:30?
Ja.
Kunnen we even de rotzooi wegbrengen?
Ja.
Want mij is het toch wel fout.
Ja, ik denk het.
Dat is niet erg. Bewegen is niet zo heel. Bewegen is goed. Hey, ze hebben een tuin, dus dan zou ik even een trui meenemen. Als een jas of zo. En je kunt er lekker zitten, maar een bepaalde wordt het koud. Ja. En ik wil het persoonlijk niet zo laat maken.
Nee, ik ook niet.
Dus voor het drinken thuis, zullen we
dat is redelijk voor het
thuis. Dat groepje tot 3 uur in de kroeg heeft
Nee,
gezeten.
half nee. Ja.
Dat er een groep in de kroeg heeft gezeten.
Ja.
Tot 3 uur.
Met Adam.
Ja, maar als je Adam bij je hebt,
dan kom je niet gauw weg.
Ja. Ja.
Hello, hello. Hello.
So thank you for coming back for the last leg of the conference of the day and of the conference. And we start with a bit of Ignite talk. And we will start by Eric right now.
Hello, this is about a blend of XML technologies with something that has nothing to do with XML. One of my hobbies is building strange electronic devices, electromechanical devices actually. And I do this under the name of Eric's Theatronics, which means electronics with a theatrical touch, which means that my devices usually have way more parts and lights and other stuff just to make them cool. There's a website address there. If you want to have a look, for most of them there are YouTube videos, so you can even see them in motion. I build things with older second-hand parts, like relays and stuff, but sometimes I use Arduinos. What are Arduinos? An Arduino is a hobby PLC, or a programming or logic controller, which is a computer especially designed to drive hardware. This was designed by an Italian company. It's completely open source and open whatever. And there are many types, from very small to reasonably big. And no, the memory numbers on there are not a typo. It's really kilobytes and not megabytes. But you can do quite a lot of things, quite a lot of amazing things in such little memory. And what is important for this is that an Arduino has pins. You can see them there, and you connect hardware to them. You program Arduino in C++, you do it on your PC, and then you transfer it with using an ISB. An Arduino program is a continuous loop. It keeps looping. And once you get behind the toy programming stage, you really want, you quickly become, you realize that what you have to do is to build a state machine. Because, for instance, when you want to delay for 1,000 seconds, you cannot do that by just saying delay, because your computer is dead and it won't, during that second, and it won't respond to anything on the input side anymore. So to encapsulate all that, you probably want to create device driver classes in C++ to do that all. So here's an example where this is useful. Assume you want to add a button and you want to detect that the button is pressed. What most people don't realize is that the button bounces. So this is a signal when your button presses. So in your device driver, you want to detect that, and you only want to report a changed state when the signal is, for instance, 20 milliseconds stable. So you build device drivers, and building device drivers is fun. That's the real programming part. But once you have them, you have to connect them to your ports and to your program and stuff like that. And that is really extremely boring. And it's repetitive, and it's very hard to do right by hand. So what I thought, what I'm going to do is I'm going to do it with a declarative approach. What you see here is a device, and it installs a device driver for something like that, an LCD display. The pin, you see pin definitions. The pin definitions go into the constructor of the class. You even see wire colors there, which has nothing to do with software, but it's sometimes very handy to know which wire goes into what pin when you do these kinds of things. What do I do with this? I run it through an Xproc pipeline, and it creates, on one hand, all the Arduino C++ code for me, all the boring parts, which are now correct, thank God. And it generates also some handy documentation tables in HTML. So, does this work? Oh my God, yes. It's a real time saver for me. And the boring parts are now finally and reliably correct, which is an enormous time saver. And it also allows some additional checks, like have I used this pin twice, for instance, things like that. And once you've done that, you spark a lot of ideas for other code generation, which you then can also include into the system. So, yes, this is doing this helped me a lot and might be an inspiration for other people doing something likewise. Thank you.
Thank you, Eric. Next is Nico.
Yeah, I'm going to switch for him and going to use my computer. Yeah. Of course.
Thank you. You are here. Too quick. Should be on now.
Okay. Thanks to Eric, I can show my presentation, which is about transpiling IXML. Thank you. So what's the reason for this was the link extractor, which I spoke about on Thursday. And it's a program that recognizes references with rule-based patterns, which suggests grammars. And this application, you can see how large it is. It has 2,700 lines of parsing expression grammar. And for that, I use the XMLPrague parser with some extensions, and that's what I'll speak about. So one thing is that the documents that we process are already XML, so they're not plain text, which means that our parser needs to accept an XML document as input and then produce another XML document as output with added markup for what it has parsed. We also use matching, so instead of parsing the whole document, we find the longest fragments in the text of the document that are correct parses of the grammar. So for instance, here I have the sentence, the conference dates are 5 June and 6 June 2026, and it will produce something like what you see below, where it has found these matches. It also can ignore existing XML markup. So here the months have already been marked up with a month element. And I keep the markup by just showing the text to the parser. And it ignores these already existing month elements. So below you see what happens. It will parse the month, but it will put another month element around it. Can we use that instead? Yes, we can. That's called opaque XML. And we use these existing month elements as non-terminals. So the grammar becomes something like what you see there. You just put month between angle brackets, and then it will recognize that month element and just put it in that position. And this is the result. How could you add these extensions to IXML? Well, you modify the IXML grammar so that these constructions are recognized, and then you modify the parser generator. The first part is easy. That's what's over there. You just say a factor can be a pre-parsed non-terminal, and then that is a name between angle brackets. I did this with the XMLPrague parser generator because that's what we used in the original project. And I tried it with the markup blitz parser generator, but I didn't succeed. I almost succeeded, but it was too time consuming. So I did something else. I transpiled IXML into XML. So what happens is, let me see if I can point. No, yeah, I can point, sort of, over there. So I have a XML grammar for IXML, which I put through the XML parser generator, which generates a parser for an IXML grammar. That's number 2. Then that's parsed. It generates a parse tree, which is then converted, where's my cursor, to a XML grammar, which is then fed into the XML parser generator, which generates a parser. That's the one on the right. And then you can put your input document into that, and you get the parsed output. So in this way, by transpiling the IXML grammar into XML, it can generate a parser generator, which under the hood uses XML, but it behaves as if it is an IXML parser generator. So what are the limitations? Well, attribute insertion is not supported, insertions are not yet supported, and most character classes, because those things do not exist in XML. But as a bonus, I've added negative look ahead, because XML does support that. So you can say something like, I want a sequence of 1 or more letters, and after that there should be something that's not a letter, but that will not actually be parsed. It's a look ahead. And that's basically what I wanted to show, that you can use any parser generator to parse IXML to a certain extent. Thank you. Yeah, you do it.
Thank you.
Should be on now.
Yep. All right. Welcome from my side. Glad you are still here. I have prepared something just from yesterday to today because it's my first time here. And yeah, I want to show you something about the PEPL network, which is a slightly different use of XML. What are we actually doing? We are trying to exchange business documents. So a relatively boring thing. Key element is those two want to exchange business documents. We have the main guy that wants to send something. We have the service provider, that is C2 and C3. And they are doing actually the technical magic. So C2 and C3, they are the XML guys. Please note that this is not necessarily all the technical detail. It could get worse. But what we're trying to achieve is a generic, interoperable, secure transmission of any kind of document with, including very important stuff like non-repudiation of origin, non-repudiation of receipt, general, of course, confidentiality, integrity, blah, 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 all that security stuff. And that is what we call e-delivery, and that is something that is in the whole European context also pushed by European Union. And so where are we actually using XML? Well, we have payloads. Payloads are, in those times, usually invoices. For example, Belgium made PEPL the mandatory transmission channel for transmitting invoices between businesses. And there we're dealing with UBL, we're dealing with cross-industry invoice and other formats. What does that mean? That means a lot of validation. So XML schema, schematron, and yeah, that's a lot of fun. Additionally, because PEPL is a generic network, we're trying to wrap things up between the service providers because it could theoretically be end-to-end encrypted. That means we are wrapping the payload in an SPDH. It's an XML format defined by GS1 in the, 20 years ago, still works. And this contains metadata so that we can interpret the content correctly. We also use something we call dynamic discovery. It's a way of finding the technical connection details of our partner, where to send the documents to. And we use something called SMP for Service Metadata Publisher. It's basically an exchange repository for connection data, and we exchange URLs, but we also exchange public certificate parts. That means, we have XML as the data format where the main payload is contained, and we use XML DSIG for representing the signatures in here. And because we are very legacy, we even have web service addressing support in there. And finally, when we have all the data that we need, we're actually transmitting it. And therefore we have, we call that thing access point. It's something like a network adapter, which is based on the AS4 protocol. AS4 is a profile of EBMS3. So a lot of XML in a lot of different places. And because the fun won't end, web service security means specifying signatures and encryption in XML. So we use that as well. And yeah, that's basically it. And if I don't do presentations, I do a lot of open source. You can see it here. Fax is my GitHub account, and most of that is actually manually coded. Just a quick disclaimer. And well, honestly, I don't get around the vibe coding stuff. We heard about Craptal yesterday. Well, I was inspired. I created jCraptal. If anyone is interested, I will, of course, align with Eamon on this. And yeah, thank you for your attention.
I don't know if it's, we didn't define the rules of the comment during the highlight session.
I just want to acknowledge Philip's contribution around the world, that so many PEPL authorities and members of PEPL authorities around the world are using his open source software successfully.
Thank you.
Yes. No. Hello, everyone. My name is Omar. I'm from Lebanon. It's actually my first time here in XML Prague. I've met a lot of very cool people, so thank you for having me. I'm here to present some of my work. I'm currently doing my master's in Zurich. So RumbleDB and JSONiq. We've been working on this at ETH. You probably might know my professor and supervisor, Dr. Ghislain Fournier. So yeah. This is supposed to be fun, so I'm just going to show you one slide. It might be a bit controversial because it's an XML conference, but yeah. What if I told you that everything you can do with XQuery on XML data, you can actually do it on JSON data using JSONiq? So yeah, I'm just going to show you how it works. So recently what we did, we actually implemented it as a Python package, so you can directly go on a Jupyter notebook and just install the JSONiq extension, JSONiq package. It's already installed. Next, you just have to create a Rumble session, and after this, you just load the JSONiq extension this time. And actually, after this, you can directly work with JSONiq cells. So I divided this demo into three parts technically. The first one, you have to create the session. The second one, you create tables. And the third one, you actually query those tables with the data that you just put into it. So here we're going to test it on 10K rows. So we have 10K values. So we just run this. It creates a new collection. We actually recently implemented Iceberg, Apache Iceberg. So it's an Iceberg table. And you can see we can also query from it. It just takes a couple of time. And of course, the data is in JSON. So yeah. But actually, a main thing that we have with JSONiq is we aim for scalability. So here I tried with 10K values, 10K rows. What I'm going to try to do next is actually multiply it. So let's try with 10 million. So here I'm going to create a new table, a new collection. And instead of 10K, I'm going to put 10 million values. So I'm going to just run all. Then you can see I recreate the session. Then I recreate the Iceberg collections. You can see here I have now the two collections, the 10K and the 10 million. It created it in like almost 5 seconds. And yeah, for the querying, it takes a bit more time. It should be approximately 13 seconds. And you can see that the data it retrieved the data, and then you can, of course, do more complex queries. I just did a very simple one where you just retrieve the data and order it in descending order. And you can see it starts with 10 million, and then it goes down. And actually, because we aim for scalability, it's something that I didn't test explicitly. I'm going to try for the first time here on stage. I'm going to try it with even more stuff, more rows. Let's try with 1 billion rows. So let's add 2 zeros here. And then here, 1 billion. Let's restart the kernel and then run all. I'm going to discover with you now how much time it takes. I have no idea. It's the first time for me doing this. So of course, it recreated the table, the kernel, the session. And yeah, it's creating the iceberg table. Actually, JSONiq got really inspired by xQuery. And what we're doing, we're like constantly having the xQuery functionalities adapted into JSONiq. And even now we're working to adapt xQuery 4.0. So yeah, as you can see, it takes some time. 1 billion is a lot. But actually, yeah, you can see that like my session, it has 20. I assigned to it 20 gigabytes of RAM. If you want more, you can have more. Since it's running locally, it will take some time. So yeah, almost 1 minute, but 1 billion values is actually a lot. But yeah, my time is almost done, so I guess we can work on it more. Thank you.
At least it didn't crash the computer. So we have a last talk before the end of the conference, which implies a reflection.
Yes, I have to unmute. Sorry. Yes, I'm here.
Test. Can you hear me? Great.
Yeah, so stage is yours.
Thank you.
Hi, Leo.
Okay.
The camera is here.
Okay. I will maximize and Liam will come later. Hi. I hope you are all fit for the last session of this conference. If not, if you're sleeping, please don't snore. Okay, everything. Yeah, we would like to give you an insight into our XML differ project, which introduce an innovative concept which does not use an static, large, complex diff algorithm, but use a modular pipeline which is embedded into a so-called matcher framework. And yeah, we would like to show it to you. Yeah, my name is Nico Kutschauer. I will make a small introduction into this presentation, and Hauke will add yeah, more about the basic architecture of our differ. And at the last session, or last part of our presentation, Liam will make a deep dive into the concept and to the innovation of our concept. So, what did we do? As I already said, we developed an XML differ, which currently takes stockbook documents, two documents, compare them, and return a combined version of this docbook. It's still docbook and contains highlighting of insertions and deletion content, and the common content, of course, is only once in the combined version. But we always had, and we choose docbook because our sponsor has docbook documents, so it's obviously. But we always had in mind that our differ should be generic, should handle all XML formats. Yes, and that's why we put everything what we should know about the vocabulary into functions. And the next step would be to replace these functions by a configuration layer so that we can just substitute it by a different configuration. Our sponsor is the BSI. It's not the British Standard Institute. It's the German Federal Office for Information Security. And yeah, it's a customer of Data Type. It's a company I work for. And yeah, we work for several years together. And since 1.5 years, the PassTube, our partner company, joined to the team. And last but not least, for the Differ project, we had the opportunity and also the need suddenly to ask Liam to join the team, and we was very happy that he accepted our invitation. So what was the motivation of the project? Well, it was not our idea that we want to have an XML differ. Someone had dreams about it, but the real use case comes from the BSI. They produce docbook. They produce technical guidelines, so-called, for specifications, and yeah, they maintain in the docbook documents and produce accessible PDFs. So far, so usually, but every time when they publish a new version, of course, they had to outline the changes comparing to the base version to the readers, and the readers are not technical guys, so yeah, you can't give them a docbook document. You can't give them a Git log, so they need some PDFs to read, and yeah, need the changes visualized in this PDF. So I go here really fast through. We, of course, consider different opportunities to implement such visualized diffing PDF. And of course, we looked at existing solutions for differs, but there was always problems. And so at the end, we come to an own solution. We should develop an own solution. And we integrate it into our existing PDF output. And the important thing is here, we have an agreement with the PSI that we will, at the end, if our diff tool is released, then we will release it as an open source project. Also, just a really rare overview of the project. I just want to show that it is just, the differ is just a really small part. It's very complicated, but it's a really small part of a bigger pipeline. And yeah, we start from a Git project, a Git repository, and then we have a preparation phase for preparing the data. And then the core differ makes its diffing magic, and the result will be passed to an existing, to the adjusting PDF output. Yeah, the important thing is here, the PDF output is not part of the differ. So, and it will also not be part of the open source project. So we will show you what came out of the differ. It's not PDF. But I will show you in the next slides some PDF results. just to give you an impression what is possible. So that's important. It's not a final PDF result of the differ, but it is possible to create something like that. And of course, the PDF output is very specific for the customer, so it doesn't make sense to make this open source. Yeah, and that's our current result. So you see very normal changes here. You have a changed paragraph, which has some word changes, and they are highlighted as in certain OERs in German, but I think it's possible to understand. And this important statement was inserted, and there was a paragraph below removed. And we have complex table changes here in this example. I think that's the most impressive thing that I wanted to show you. There was a column moved from the left side to the right side. There was 2 rows added, and there was the row span expanded. It was really head-breaking, but it almost works. There are sometimes not really completely correctly visualized, but I got always a correct table model. And yeah, but there's another important thing. The major logic is currently in the PDF. We would like to shift it into the core differ, but we need more ideas, and yeah. And the last one shows you, last example I wanted to show you is a moved section. So this, on the bottom, the section is just a placeholder. So it just says this section is moved to, is now the section 10.1.1. And on the top, you see this moved section. Between there's more content. I skipped them out. And you see here also that in this moved section, there was a typo. So the typo was corrected in the moved section. So it is something like a nested change. And yeah, it's like a bit, of course, it's a link, so you can jump between these sections, because there at the top is also an origin position link to it. Yes, and now Hauke will give us more an introduction into the basic architecture of our differ. Thanks.
Thank you. So since the time is already a little bit advanced, I will spare you the boring theory behind it. It's suffice to say that the basic idea of almost any diffing algorithm is to create a series of operations, of atomic steps that are needed to get from some kind of source document to some kind of target document. And in addition to that, it would be nice if this sequence of operations had some nice properties. For example, it could be a minimal number of steps, or all steps are remarkably simple, or things like that. So, concretely, the center part of the architecture that you've seen is our differ, and the differ gets as input one document in 2 different edit states, so an older version and a newer version, an edited version, usually. And the return of the differ is the target document, but it is annotated with processing instructions that basically describe how we got from the source document to the target document. So this is a little bit of the inner architecture. You can see that we've got two data structures. First of all, we look at both the input documents. So one of the documents is the tree above, and the other is the tree below. And we find corresponding nodes in both documents. So in this step, no operations, no edit operations are created at all. we just say, well, this section corresponds to this, in the source document corresponds to this section in the target document. Or even this word in this paragraph in the source document corresponds to that word in the target document. So this is the first processing step, the generation of a set of matches, which are basically mostly pairs of nodes from the source and the target document. This is the input for the next step of the pipeline, the edit script maker. The edit script maker just takes the sets of matches and generates a sequence of operations, how to get from the source to the target document. This is really just a list of very simple operations like insert, delete, or which was important for us also to be able to express moves. So we can say that one section has been moved to a place later in the document. Yes, the sequence of operations then gets fed into the next and basically last part of the differ, and that is the patcher. The patcher gets as input the base document and the list of operations. So implicitly, it knows how the target document needs to look like, because this is the result of applying the operations to the base document. And what it results in is just the generation of the processing instructions in the structure of the target document. So as I said, I will do it a little bit more quick. We can see this is the internal representation of our basic steps. We've got a simplified path format for addressing the nodes. I think this is all rather straightforward. And these are example results. So we can see here we've got a processing instruction that says that this word in has been inserted. It was not present in the source document, but it is present in the target document. You can see that these processing instructions are prefixed with oxy. We used a similar feature from Oxygen as an inspiration, and we are basically compatible. We have some extensions that are not present in Oxygen, especially considering that we can express moves, which Oxygen cannot do. If some content has been removed from the source document, it is not present in the target document, but we want to have all the information, what has been done, also what has been deleted in the target document. So what we do is, if there is something deleted, we put the serialized version of what has been deleted in the processing instruction. So we can basically reconstruct the source document also from the annotated version here, even if there's content missing. And this is the extension that we have defined for expressing moves. Moves are basically a pair of insert and delete operations, of course, but they are linked together by a unique generated ID. So if this section has been moved to this place, we have here an annotation that says here's a new section that has been created, but the move ID says there is a corresponding delete somewhere in this document, and that signifies where that content came from. And as Nico has shown in the examples already, this can also be nested. So in the moved section here, we see that we have got additional annotations that mark up that the section has not only been moved, but also modified. So just some facts. Most of the part of the implementation has been done in XQuery. We are using the base X implementation, and a good part of the XQuery 4 extensions, for example, records, but Liam will talk about that as well. There's a classic paper from 1996 which informed parts of the basic architecture, mostly the separation into a matching phase where we only find corresponding pairs, and from the set of matches to generate an edit script from that. This paper was very fuzzy or, well, it was not detailed in the matching part. It was very detailed and basically constructive on the generation of an edit script. So you could use it as an implementation recipe. For that part, the more interesting and more important part was the matcher, and Liam will now talk about that, I think. Yes. So, Liam, it's up to you now.
Hello. You can see me. I'm terribly sorry, and you can hear me. Can you hear me? Yeah. Okay. And I think we have not much time left. Am I right? Okay. All right. So I'll talk about the matcher. I'm sorry I couldn't be in Prague, so I'll try and guess that the audience is happy. So the purpose of the matcher component of this project is to mark corresponding nodes. It gets two input documents. One's the original and one is the changed. And the method that we came up with was a pipeline of matcher functions. As Håkon mentioned, the paper that we started with basically left writing the matcher as an exercise for the reader. It was kind of like an undergraduate maths textbook, you know, so solving the halting problem is left as an exercise for the reader, with a note saying the quality of the matcher function that you write determines whether the algorithm works or not, which so it wasn't very helpful. So we came up with an open architecture. You can write your own matcher functions, and you can run the provided ones in any order, even multiple times. It means, for example, you could go out to something external if you wanted to, for example, a database, to find that two, based on some attribute or content or whatever, to find that two elements correspond. So it's quite open. Slide 21. Someone else will have to go forward. Yeah, thanks. I wrote a framework to run the matcher, and I wrote most of the matchers, but not all. Nico did the hard one, right? My goal was that it should be really easy to add new matcher functions. My goal was writing code is always that the code should be easy to understand, which is more important than correct code, because if your code is readable, you can fix it. If you can't understand the code, then you can't fix it. There's constraints on performance because some of the algorithms to do with diff algorithms are n squared, and some of them are NP complete. I showed that one of them was isomorphic to the bin packing algorithm, for example, which is strongly NP complete. And which means that if you have a large document, you could be waiting a long time. So we didn't use that algorithm. And again, no out of memory errors for reasonable documents. One of our test documents was my famous Chalmers dictionary biography, which is 40 megabytes, just to make sure that it didn't explode. And to isolate people writing matchers, which could be us, or it could be you if you use this software, I wrote a functional API, an API based on functions. Okay, slide 22. The clients, as mentioned, this was done for a client, and also I had a client which was data to type and Parsecube. Every node in the document had to be marked identical. That was a requirement for the matcher, or marked as corresponding, a match. We couldn't just have nodes that were floating and we didn't know why they were there in the document. So the whole document had to be resolved. In the future, we might special case wrap and unwrap and split and join, which are as well as move and change and insert and delete. And the result had to be correct. It couldn't say, it had to find everything that was changed. It couldn't skip changes, even if that slowed it down. Couldn't slow it down to be glacial, but it could slow it down. Okay, slide 23. Adding matchers right now means adding to a variable. So here's a little fragment of X query. we have matcher definitions as a map, and it actually carries on kind of several floors below or something. You've got it really big, so it goes well below the screen. But I've just shown the first entry here, which is for find pairs, and each entry is a map with 2 items. Matcher here is a function called find pairs with 3 arguments. I'll talk about them in a sec. And the about finds paragraphs with identical content. I wanted to show this because it's a useful technique. It's kind of like a symbol table, so that we can take a list of matches to run and look them up in here and run them. But we can also take a list of matches, which is just the keyword list, and then it prints all of the names and the descriptions so that you can find out what the different matches do. So this is quite a useful technique. Matcher definitions, the matcher functions on slide 24 take 3 arguments. So first argument is a match box, which is a map of all the knowledge gained so far. And it also takes 2 document nodes. And it returns a new matchbox map, which is rewritten with the new knowledge added to it. So with map::put, of course. In some runs, I measured over 1 million map::put calls, for example. And the matchbox itself, it's a box containing matches, a sort of bad joke, is an XQuery4 record type, so that we can get some extra type checking. And that's very, very useful. In slide 25, one thing that these matcher functions do, so they walk the tree finding differences and then return a new state of knowledge. And I kind of missed the apply templates instruction in XSLT. So I added a visitor pattern module for walking document trees, and you give it functions for different kinds of nodes and it calls them. You can also give it a function to say, ignore this node and its children, and then it won't descend, which is something you can't so easily do with for each or fold left. You can wrap, in fold left, you can wrap an if around a recursion, so you can do it. What you can't do in for each or in a flower or a fold left is look at the values so far for each new value. And that was something I needed to be able to do. So that's where the visitor pattern can be a win. I guess you can do it with fold left, but then you have the problem if you can't do an early exit. So, I mean, they each have advantages and disadvantages. All right. So find pairs I mentioned before. It's just an easy to understand example of a matcher. It walks the document with a visitor and builds a map of normalized text values. And it's compare, and for each normalized text values as the key. For each normalized text value, there's 2 arrays, one of nodes in document 1 and one of nodes in document 2 that have that text value. And at the end, it goes through them, and if a key has 1 node in each document, we call them tentatively matched. And that going through process is repeated as after later matches. Another one is matched by ID. I'll only mention about this, the last point on the slide, which is that it uses XML semantics, ID and XML ID by default, but we're working on a configuration file. So that's an unusual thing of this matcher, as it can make extensive use of XML semantics. Okay, 28, a more complicated matcher, and I'm just going to go straight through to 29, which has got a picture, and talk about it. So in this picture, what the matcher is considering is the leftmost section in the diagram, and the topmost section, the arrows here indicate matches that have already been found. So for example, paragraph 2 has been tentatively matched with one in another section. Paragraph 4 has been tentatively matched with one in another section. And each match has a confidence value, which is a floating point number. So if it's been matched with low confidence, we can say that the top section has got 3 things matched, one of which title is spelled differently. But although I don't show the contents of the paragraphs here, we're using text similarity in rather like Apache Lucene with cosine vectors and stemming that I translated from a paper. It works quite well. So these things can be quite complicated. They can be quite sophisticated, I should say. On slide 30, they make use of a configurable list, actually several configurable lists of elements. And similar elements can match, but you would not, for example, want to match a chapter with an emphasis element. That wouldn't be right. And titles are treated specially, as are tables. Titles in particular, section titles, are weighted more heavily than paragraphs in them, so the whole section probably matches. Internally, there's, I mentioned before, an API based on functions, and functions on all the functions return, almost all the functions return a new matchbox record. Some of them, like is paragraph like, are there to support changing the input vocabulary. So you ask if an element is paragraph like. There's a list of elements that might be. And all the logic around adding a new match is in a thing called match object, which again returns a new matchbox using map::put. This greatly simplified development, and having the record types and the error checking and optional tracing really helped speed up development. So on slide 32, oh, sorry, I forgot to tell you to go forward a slide. Right now, successfully, all elements are coming out matched, I'm told. Within a paragraph, there's a very clever inline matcher that Nico wrote based on the Myers diff algorithm. It's okay that this is this is computationally slow because it only runs within one paragraph. All right, so it's not running on large amounts of input and is small. Sometimes changes appear as insertions and deletions when they should appear as changes. It's not perfect. More matches could be written, but I think it's got a lot better in the last month or so. It is easy to add new matches. Debugging them can be hard. One of the hardest things I found before we used more extensive use of record types was that else is now optional in base X. And so if you leave the else off, you get an empty sequence returned, and I didn't want one. The matchers can use domain-specific knowledge, which is, I think, unique to this particular differ. And we're currently working on a configuration. All right, I think my last slide before the questions is 33. I might as well save time and do it. So we've written an open XML differ. It's in XQuery. We hope it will be open source soon. You can add your own match functions. It gets reasonable results. It can, obviously, any work of humans can be improved, but it's pretty good. Performance, it takes a few seconds. My 40 megabyte document can take up to a minute, but that's okay. Conceptually, comparing two 40 megabyte documents doesn't need to be instant in most cases. And it's continuing to improve. So I hope that gives you an idea. Thank you.
I don't know if we have a few questions. No. Oh, one question.
Interesting talk, thank you. You have post-processing, creating a PDF using XLFO. So I guess you converging the processing instructions to EVO inline, right?
Yes.
Can you ensure that there is no overlapping markup?
You mean that there could be some inwell-formedness? Or did I understand correctly?
Yeah,
Yes.
well, yes.
Well, in the processing instruction, there is always a well-formed snippet of XML. So the main problem in the PDF output is that it could be there, for instance, if you remove a title and insert a title, then you have two titles. So you have to handle this in the post-processing instruction, in the post-process.
Yeah, I've been using DocBook for 20-something years, and I have attempted to write a differ for it at least 3 times, and this looks substantially better than anything I ever managed. So great work. I'm looking forward to playing with it.
Thank you.
Oh. Yuri.
So I was especially impressed by the table diffing that you did. Even though you said it's not perfect, but no, it looks really interesting. And you said that it's not part of the core differ yet.
At the
and you
moment,
need
yes.
more ideas. What are these ideas that you need? I want this.
Well, it was really, really heartbreaking. And yeah, there's a switch in where I running out and screaming if this is too complex. So if it's not mergeable, the table, then it duplicates the table. And yeah, to integrate this in the matcher, we have to adjust the concept, because at the moment we just can compare nodes and create the existing nodes. But for the table, I had sometimes to create empty tables to fix the table layout. And this has to be integrated in the matcher, and not in the matcher, we are not sure where we integrate it. Of this in matcher or in the edit script maker. And yeah, we have to think about it. But the good thing is I had now a solution for the PDF, and I had the pain already. And now I can, maybe the pain is not so hard again.
And since the fallback just makes a deletion of the old table and insertion of the new table, it is always correct. It may not look as nice as it could be, but it is always a corrective.
Thank you very much.
All right, thank you. Bye.
Thank you. So thank you very much all. It was the last talk. Thank you for attending to this 2026 edition. Thank you all. Everyone who helped is not there, but you have a part of the XML Prague family in front of you. Thank you very much all for traveling there, for joining, for being happy, sad, everything. Thank you very much. And
submitting papers, doing presentations.
Sorry?
Submitting papers, doing presentations.
Submitting papers during the presentation. Sponsoring.
Eating almost everything.
Eating everything.
Dancing.
Singing, being to the dinner, and so on and so forth. Thank you very much.